Alright. All right. So much to do, so much to see. And we still gotta catch them all to be the best that we can be. That's Pokemon. A-do-do-do. A-do-do-do. Excuse me. Anyway. Oh boy. Oh boy. Did this have any scripts already? No. It has this course library thing here, but... none of these have scripts attached to them. They have animations, though. These have animations connected to them already, though? No. I'm just kind of looking over what we have here. Much prematurely. Create a scripts folder. We'll have that there. Should I make something that says prefabs or materials? I feel like I don't need to. I just figured might as well take care of the small stuff right away. I figured today might as well focus on Unity creation instead of worrying about writing, because I got that story done yesterday. So I might as well focus on Unity today, because I didn't get to it yesterday. So hopefully we'll have a nice long session today. Maybe we can get through this first unit. But we'll see how that goes. So once again, actually let me turn on my game dev knowledge document. So don't forget about that. Excuse me. I only had a pretzel, pretty much. A soft pretzel. I don't know why it's making me burp. Put my game dev knowledge document up. Drag that over. Okay, I got all that. We don't have any scripts up, so we don't have anything there yet. So I'm just gonna play through the videos now. Mute while we go through it. I think, I don't know, should I try and watch them all, even if I already know it from the Essentials course? I'm not sure. But we're gonna start this off anyway.
As usual, since we're starting a brand new prototype, the first thing we'll do is make some creative decisions. The basic premise here is that a character is running and jumping over things. But will it be a farmer jumping over crates in the wilderness, a construction worker jumping over barrels in a quaint town, a guy in a suit jumping over giant spools in a big city? These are decisions that only you can make. But after you've done that, we've got a lot of programming to do. Because by the end of this lesson, you will be able to press spacebar to jump over obstacles as they fly towards your character at high speeds. Now, we've moved objects around before, we've moved a vehicle left and right, we've made animals and food fly across the screen, but we use the translate method to do all of those things. And the translate method essentially drags the object through the scene at a particular speed, regardless of any laws of physics or how heavy it is. The way we're going to make this character jump is completely different. In order to get that smooth, realistic looking falling motion, we'll have to rely on Unity's physics engine, which takes into account the mass of an object, any forces acting on it, and gravity itself. So instead of translating this character up and down, we'll call the add force method to apply a single upward force on the character's mass, and then sit back and let the simulated force of gravity do its thing. So to make all that happen, I'll see you in Unity. Alright, so let's get started with Prototype 3. Now I'm going to import the project files and set up my new Unity project, but since we've already done that, let me just open up Unity so that we can get going. Now I'm going to go into the Scenes folder underneath my project window, open up Prototype 3 by double-clicking on it. I'm going to delete my sample scene by right-clicking on it. Delete. Let me reposition my camera here. Oh, I'm on the other side. Okay, cool. So that looks like what's in our game view. And then last but not least, once I've had all of my assets imported, you can actually select the background object in the scene. On the right side, you'll see in the inspector for the background, this sprite renderer. Now a sprite renderer is a component that enables you to render or to see images in your game and in your environment. So in this case, we have this background image. So we use our sprite renderer to actually see that image in our scene. Especially when you're making 2D games, sprite renderers are particularly useful if you have a character with items or they're carrying something. So with our sprite renderer, on the right, there's a little property called sprite, and you can see currently it's set to background town. All the way on the right side of the inspector, there's this little circle icon. It's a radio button, so you can actually click on it. And there are all these different options. So there's in fact actually 3 different backgrounds we can use, so you can select one that works for you best. I kind of like this forest scene. It's very natural. It's got a lot of bright colors on it. So now I can just close out of this window, and we have a background selected. Alright, so what you're going to do is open up the Unity Hub and create a new Prototype 3 project. Use the link below. Cool, so we've chosen a background for our project, so we're good to get started. Now we need to give the scene a little bit of life, so we're going to add a character for the player to control. So in our course library, we have our characters, and we have the choice between farm or town. So I'm just going to go with farm characters, and we'll just, I think that one looks good. So we're just going to drag that into our hierarchy. Cool. So now what we're going to do is we're going to rename this to our player, just like we did with some of our other players. And our farmer is kind of facing towards the back, and that's not what we want to do at all. So if we just turn the farmer, let's just say like 90 degrees. So now it looks like the farmer's facing forward. Cool. Perfect. Awesome. Now, one of the things that I'm going to do, just because I know I'm going to need these later, is I'm actually just going to add a rigid body component now. And then I'm also going to add a box collider. And let's see where that box collider is. It's very small. It's on the character's feet, which is definitely not where we want that to be. So let's bring that up to about the center. And then we'll make that a little bit larger. We'll make the Z a bit larger, and then we'll just make sure that the Y is properly set up. Cool. Looks just about right. Okay, awesome. So now that we have our box collider set up on our player, one of the things that we're going to do is create another scripts folder by right-clicking on Assets. And we're going to need a player controller script to actually move our player. And then we'll just make sure that we attach our player controller script to our player. Click on the player and make sure it's there. Perfect. So now what you're going to do is you're going to select your own character and add them to the scene through the hierarchy. That way they're at 0, 0, 0. You're going to rotate your character on the Y-axis, so then that way they're facing in the direction that we want them to. Make sure you rename your player character. add a rigid body to the player, and we're going to keep gravity on. Add a box collider and just make sure that the box collider fits within the character. And then you're going to make a scripts folder in assets and create your own player controller script. So now it's your turn. Cool, so we have our player set up as much as possible for now. So in the past, we've commonly gotten just the game object or the transform component whenever we wanted to call any methods. But if we want to actually control the movement and the gravity of the player and all of that, we actually need to use a new way to get a component for our rigid body, because rigid bodies aren't something that are automatically on other game objects versus something like a transform, which is always on game objects. So we'll do that using our player controller script. So in our player controller script, we're going to create a new variable. I already know that I don't need this to be seen by anything outside of this class, so I'm going to name this private for now. And then it's actually going to be our rigid body. So this will be the rigid body component on our player, similar to how we had attached game objects before, but in this case, this is a rigid body. And we're going to just name this player RB for player rigid body. Now, versus something like transform, where we can already get access to our transform component, we don't automatically get access to our rigid body component because that's not something on every single game object. So in order to do that, we actually need to use something called getComponent. So if we take our player RB variable for a rigid body, and now if we assign that or set that to the component of our rigid body, so we use a method called getComponent. Now we have to use these left and right carets here, which is different than using parentheses to pass in parameters. Specifically, the left and right carets actually get you a type of something. So for example, in this case, we're getting a rigid body, but you could use these carets to find the type of anything. So if we actually want to get a collider, for example, that was on our player, we could do that too. So the carets are specifically for finding different things like our components that are on our different objects. Now we do need to close this with a parentheses because it is actually a call that we're making as a method. And we'll close that statement. And then just to test and see if this works, if we actually got that rigid body, we're going to apply a force to our rigid body.
Now, because we're using a rigid body component, it already has a method called add force. And you can think of this similar as transform.translate, but instead of moving something physically just using positions, we can apply forces to things just like we would in the real world using physics to make something move. So in this case, we're going to make our player move up just to see what happens. So we're going to use vector3 dot up, and we're going to amplify this by a lot. So we'll just multiply this by 100. And then we'll save. And now in Unity, if we look at our game view, when I press play, the character jumped very slightly. Let's see if we can make that a little bit more powerful. Let's set this to something like 1000. And we'll save. And now back in Unity, we'll press play. There you go. That's a lot of force. And then because he has gravity, the character falls all the way back down to the ground. We'll do that one more time. Woo! It's like he's so excited. Cool. So what you're going to do is going into your player controller script. In your player controller script, you're going to make a private rigid body.
Sorry if I'm not saying much. Just trying to get through this all. Absorb the information. Trying to do the watch then do thing. But yeah. So I got Visual Studio up now. Okay, so let's see. They want us to make a little class thing, a variable thing, whatever you want to call it. So we'll make a private rigid body. Oh. Make that player. That's the player rigid body. And then in the start area, we want to make the player rigid body equal get components. Rigid body. The parentheses on that, and then add the force. Add force. Vector 3 up times 1000, and then semicolon. Yeah. Make a little note for myself, makes the character shoot up and fall back down. And we'll just test that ourselves here as well. Got a green screen. Got rigid body stuff. Got a box collider. Well, let me just see. Is box collider looking okay? It's probably good. Probably as good as I'm gonna get that. Okay, so rigid body's up, that's up, and then we hit play. And they do shoot up. Oh, they're gonna make us change it anyways right away. I guess that's more to show us how we do it. Anyway, we'll get to this. I mean, I figured they would make us apply it to the spacebar anyway. So, in mode. Engage.
Cool, so we're making some good progress. We've added the rigid body to the player so we can use forces. So when we press play, our player flies all the way into the air and then drops all the way back down. Now we're going to make it so we can use input from the player to actually control this jump. So if we go back into our player controller script, we're going to go into our update method and we're going to use an if statement. And in that if statement, we're going to check whenever the player presses the space bar. So using our input manager, we're going to get the key down. So when they press that key down, and the key that we actually want is going to be our space bar. So we're going to get the key code for that. And then I think it's just called space. There you go. And then inside of our if statement, now what we're actually going to do is we're just going to take our add force, cut it out of start, so that way the player doesn't just jump when it starts, although we could do that because that'd be fun. And in our if statement, we'll make it so that the player jumps whenever we press space. Now, one slight change that we can make to this to make it a lot more immediate when the player jumps is by actually changing our add force method just a little bit. So we're going to drop this back down to 100, we'll say maybe 10 for now. So you can see when we were originally passing in this parameter, we were just passing in a vector 3. But you can see when we added this comma that we can actually add in a force mode. And so we can actually apply different forces through this force mode. So in fact, if we actually type in, oh, it auto completes force mode for us, which is pretty nice. So we'll just type force mode. And then we're actually going to apply an impulse force. Now there's 4 different kinds of forces that you can apply. There's a normal force mode, which applies that force over time. In this case, force mode impulse immediately applies the force that we want to apply. So in this case, you should see that player jump happen a little bit faster. So if we go back into Unity, if we go to our player and we focus on them, and then we play our game. Now when we press space, you can see that the player jumps almost immediately, and we in fact actually need less force because we're not trying to apply a force over time, we're just applying that force right now. So immediately they get to 10. So what you're going to do is you're going to add in your own if statement to get the spacebar input. And then you're going to move that add force method from start down into our update method inside the if statement. And you're going to change the parameters that you're putting in so that it's a vector 3 up times 10. And you're applying the force mode as an impulse. Now it's your turn. Cool, so we can make the player jump. He looks so happy. I'd be jumping for joy right now. So what we're going to do is, in our code, So you can see when the player jumps, we have this 10, which is a hard-coded value. We don't like that. So we're going to change this to a variable in case we want to change the amount of force we want to apply going up. So we'll make this public so we can see it and mess around with it. It's going to be a float. And then we're just going to call this jump force because it'll be the force of our jump. And we will set this to 10 for now so that way we can hold it. We're going to remove the 10 and call this jump force. Perfect. Now, one more thing that we're going to do is in our start method, one of the cool things that we can do is actually change the gravity of our physics. So what we can do is we can call physics. So this will actually get all of the physics in our game in Unity. And we can actually get gravity by typing .gravity. So it's a property of our physics. And then we can type in star equals. So if we hold Shift on 8, it'll make that star. So that means multiply equals. And then if we type in something like our gravity modifier, so this will be a variable that we'll set later. So we have this weird statement right here, and we've definitely seen a lot of interesting symbols, and this one is definitely a new one. So this is actually a shorter-hand way of saying physics.gravity equals physics.gravity times gravity modifier. So instead of saying this twice, which could both be really confusing and is redundant, we can actually just short form this by saying times equals. So this will be physics.gravity equals physics.gravity times gravity modifier. So we'll get rid of that statement because we don't need it. And we'll go into our variables and we'll set gravity modifier. So it'll be public so we can mess around with the gravity. This will be a float as well. And then we'll use gravity modifier. Cool. Now, when we go back into Unity, so you can see in our player, on our player controller script, we have the jump force and the gravity modifier. So when we press play, if we press space, our player jumps and they're still going. They're never coming down, just forever and ever into the distance. Maybe he might make it to space one day. So, actually, because we multiplied our physics gravity by 0, there's actually no gravity at all. What we actually want to do is if we stop playing, and we'll bring our focus back on the player, and we don't want that view, so let's, there you go, reorient the camera. So if we actually want real physics, we'll set this to 1. So this will actually set it so that the gravity is what gravity normally would be. And now when we press space, the player should jump exactly as they did before. Cool. Now they're jumping a little slow and it looks kind of weird, so we'll actually, let's set this to like 1.5. And then we press space. There you go. It looks a little bit better. Maybe if we set this to like 2 and the jump force, and their player fell over. Let's see if we set the gravity to twice as much, and then we set this to like 15, and now we jump, and there's still a lot. But our player looks really happy, so, you know, can't complain about that. So now what you're going to do in your player controller script, you're going to add a jump force variable so we can get rid of this hard-coded number right here. Down in our update method, you're going to make a gravity modifier variable so that you can set the gravity to be whatever you want it to be. And then in your start method, you're actually going to set the gravity of our physics system and multiply it by our gravity modifier so that we can change how much or little gravity there is in our game. So, now it's your turn. So, we've made it so that our player can jump in the scene and they look so excited. Look at them go. But a funny little thing that you can do is because we're just looking for whenever the spacebar is down, the character just goes up. In fact, if we just keep pressing spacebar, our player will just fly off into space. It's very fitting. And then eventually they'll come down. But I think we've actually applied too much force. So, we need to actually fix that, and we'll have to use some of our coding skills to do so. So, in our player controller, we're going to create a new variable. And this one will be public so we can see what it does. And we're going to use something called a bool, which is short for Boolean. We'll get into that in a bit, but for now we'll call it is on ground so that we know the player is on the ground. And we're going to set this equal to true. Now, a Boolean value is another kind of data type, just like an integer is for whole numbers, floats are for decimals. A bool is simply a value that holds true or false. This is particularly useful whenever we have our conditional statements that are trying to check if something is true. So what we can do is, in our if statement, we can actually add some code in here. So, for example, when the spacebar is down, this condition is true, and it'll add the player force to make the player jump. We can use two ampersand symbols, which if you hold shift and press 7 twice, this means and then if we type is on ground, so this means that whenever the player is on the ground and whenever they press the spacebar, we'll then apply that force to make them jump instead of letting them be able to fly off into space. One more thing that we're going to add in our if statement is when the player jumps, we're going to set is on ground to false. So now in our update function, we'll know that when the player jumps, they're no longer on the ground, and so therefore, because is on ground is false, this entire statement will not be true. And so it won't let you actually jump again. The only downside is that we never actually set is on ground back to true. So we're actually going to use our collisions again. So since we have a collider on the player and we have colliders on the ground, we know that when the player touches the ground, that they've entered the collider box for the ground. So if we type private void on collision enter, and conveniently Visual Studio auto completes for me the entire method, so I don't have to write all of that out myself. So whenever the player enters a collision with something, now we can set our is on ground to true. Now if we save this and we go back to Unity, and in our scene view, we'll bring our focus back to the player and we'll get a better angle. There you go. So we can watch this is on ground variable down here, this Boolean. And right now, since it's true, it's checked off. We know we're on the ground. And when we press space, is on ground is unchecked. When we land back on the ground, is on ground is checked. So it's another good reason to jump for joy. Cool. So now what you're going to do is you're going to create your own Boolean variable called is on ground, and we're going to set that to true. In our if statement, you're going to use two ampersand symbols. Remember, hold Shift and 7, and then you're going to add is on ground, so that way it's another statement that also has to be true within this if statement. When the player jumps, you're going to set is on ground to false. And then using our colliders, we know when the player is on the ground and when they're not. So you're going to use the on collision enter method, and then you're going to set is on ground back to true when the player collides with the ground. Now it's your turn.
Huh. Well, these parts have been interesting so far. I was wondering for a long time if they had an and statement. Go figure that the and statement is just the and symbol, but twice. I wonder why the and symbol has to be twice. Does and by itself mean something else, I wonder? But now I'll make the obstacle and move it left. Okay. So, let's see how this is. So, since they have gravity and a collider, no matter what, they'll fall back to the ground. And even if I didn't have the box collider, correct, the feet would just go through the ground then, until it hits the box collider. So then when we press jump, it'll turn that to false, and then when you land on the ground, it turns it back on. So you can see down here is on ground. Has a check mark on it right now, but when we hit space, it turns off, and then when we hit the ground again, it's back on. So we can jump. And since it's false, we can't jump twice in the air. We can only jump when we're back on the ground again. Okay. That makes sense to me. That's pretty neat. I was curious how those kinds of functions worked. Though I'm also curious if the character was falling in a 3D space then, or whatever, like, how do you make it not fall over? Is what I wonder. Because, like, when I was trying to set up my own player controller, when I was jumping, the jump would work, but then they would fall back to the ground, and, you know, they would just fall over. And you wouldn't want your character to fall over. Maybe in your animations, when they fall back to the ground, you could have them, like, roll on their shoulder or something. But that would be an animation. That wouldn't make the box collider fall and become, you know, a rectangle. So I wonder if that's explained later. Or if you would just have to be like, okay, so you'd have to make tons of bool statements saying that when they jump in the air, they have to stay in this orientation and then they fall back down. No matter what, they go back to this orientation. With like a transformation thing or something. That's what I could try to think of it as, but I'm not sure. Well, let's get back in.
Cool, so we've got our little character here in the forest, hopping along in the great outdoors. So happy to be outside, wild and free. Now, what we're going to do is we're going to add some obstacles to make this a little bit more game-like. So we're going to go into our assets folder, go to our obstacles. Let's go... kind of like this barrier. Kind of looks like a fence. So we'll go and drop this into our hierarchy. And we're just going to position this a little farther back. Let's put it at like the edge of the screen, like right there. Cool, perfect. So now that we have our barrier, you can see that it has nothing for components. So we're going to have to add some things like a box collider so that the player can collide with it. Cool, and we'll just resize this box collider really quick. So we've set up our box collider so that it looks really nice. Cool, that's perfect. Now we're actually going to add a rigid body. So now this is an actual physical object in the scene that the player can actually run into and collide with, and it'll use physics, so it might topple over if you run into it. If you notice, we actually didn't check the is trigger box on the box collider. That's because this isn't actually a collider that will have us destroy the object or anything. It's just so that we know when we run into it. And then we're just going to rename this barrier, this fence really quick, and we're going to call it obstacle. Now what we're going to do is in our assets folder, we're going to make a prefab because we're going to use this again. So we're going to make a prefabs folder. And then we'll take our obstacle and we'll left click, drag it down into prefabs. So now we'll make an original prefab. And here you can see that we have this fence saved. And now that we have this prefab saved, we're actually going to make it move in the scene. So we're going to make a script and we'll call it move left. Very simple name because it'll just make things move left. So now we'll take the move left script, apply it to our obstacle, and then just make sure that we override our obstacle to apply to all of our prefabs. And then in our move left script, we're just going to open it up really quick. Now inside of our move left script, we're going to create a variable for speed. So this will just be private, and it'll be a float because we can always just edit it inside of our code later. We'll call it speed, and we'll set it to 30 for now. And then we're actually going to move this using our transform.translate once again, instead of trying to use physics to move a fence. So we'll just transform, translate like we always do. And then we're going to move it to the left since the fence is to the right of the player. So vector 3 dot left. We want this to move over time instead of moving every single frame. So we'll use time.delta time. And then we'll move it at the speed that we set. And then if we save, so now in Unity, when we press play, our fence flies at a really fast speed at the player, and I think it's just flying off in the distance. There it goes. Oh, there it goes. It comes back. It's like it's haunted. So we can always change the speed of that to something less later. What we can do for now is, because we're actually making it look like the player is running, we're actually just going to move everything around the player to make it look like they're running. So if we actually take this move left script and we apply it to our background, this now creates the illusion when we press play that our player is running through the scene, even though in fact the player's not moving at all. You're going to make the player look like they're moving. So what you're going to do is grab an obstacle from the obstacles folder, create it, make sure that you add a box collider, a rigid body. If you want, you can even add the move left script now and add it to your scripts folder. And then you can create your prefabs folder, drag the obstacle down into prefabs. And then your move left script, you're going to give it a speed. So just set it for 30 for now. In your update method, you're just going to move it through translating the transform. So we're going to move it to the left over time at a certain speed. And then a nice little effect that you can do is on your background, you can actually add the move left script. So then that way when you press play, it looks like the player is moving to the right when in fact everything else is moving to the left. Now it's your turn.
Hello, Jordan. Hello. I'm just, learning. That is what is going on. Learning is happening. I wonder why they don't just have you do a spawn right away, and this is to teach you how to loop certain objects, I guess. I feel like you would just make a random range to do that, though. To just set the time that it spawns in the object or something. I don't know. Anyway. We renamed the obstacle, we positioned it where it should spawn. We applied those. We created a new prefab. And now we need to move left script. So that's what we need to do. Left. That is not what I wanted. Okay, apply that to all, and then we will use the move left. Ugh. Throw up. I'll make a private float and set it to 30 for now. How many private floats do you have? And then we want to change the update to a transform translate. And we'll have our vector. Three left. And then we want to times it by time delta and speed. And our semicolon. Okay, so we got that up. It's all good now. Yeah. I don't know why you would shave your poop, but, I guess if your poop's hairy, you know, do whatever you gotta do. Do whatever you gotta do. Okay, and then we want to apply the move left to the background as well. And I will play and everything should zoom by. That was funny. The character just falls over and dies. Ah, I think I dodged it that time. Well, that is going way too fast. But, we'll keep following the videos instead of changing things right away. Create a spawn manager. Okay, this is what we figured would happen. So they are going to still have a spawn manager. But wouldn't we have to remove... Well, no, I guess we wouldn't have to remove it. If it's just infinitely spawning the same background. I guess that would technically be looping it if you destroy the old one then. Well, learn mode.
Alright, so we have it so that it looks like the player is running through the scene, when in fact everything is actually just flying at the player. So, now what we're going to do is we're actually going to use a spawn manager to be able to create more obstacles that fly at the player. So to do that, we're going to go into our hierarchy, and we can just right click and create empty. Now we have an empty game object, and this will be our spawn manager. And then in our scripts, we're going to make a spawn manager script. And then just make sure to click and drag that onto our spawn manager. So now that we know it's been added as a component, so we'll open our spawn manager up. So in our script, we're going to need a reference to our obstacle. So we need to make it public so that we can drop that reference in there. And since it's a prefab, we have to use a game object. And then we'll just call this obstacle prefab for now. And then close that. Now we're going to create another variable, very similar to a variable that we made before. So this will be private, so we can just set it whenever we want inside of our code. It'll be a vector3 because we're doing a position. And this will be the spawn position for our obstacles. And we'll set this to be a new vector3 since we're getting another position. And we'll set it to, let's call it 25 on the X so that it's all the way on the right side of the screen. We don't need it in the air, so 0 on the Y. And then we don't need any kind of depth towards us, so we'll call it 0 on the Z. And then in our start method, we're going to create that prefab once again using our instantiate method. So this way we can create clones or copies of our obstacle prefab. The object that we're going to create is our obstacle prefab, which we listed above. We're going to have it spawn at the position that we set in our variable. And we want it to be facing the same direction that we set it when we created this prefab. So get the obstacle prefab. We're going to get its transform component, and we'll get the rotation of our prefab. So you can see back in Unity, in our spawn manager script, it's updated to have that instantiate method. It's got our variables. So now when we press play, our obstacle should fly at us, and we should create another one. I only see one obstacle. There goes our fence. Interesting. So at the bottom here, it says that there was an unassigned reference exception. So this red exclamation point means that it was an error. And it says that our obstacle prefab wasn't assigned. Obstacle prefab of spawn manager. So I think actually what happened in our spawn manager, I see. So I didn't actually drag the obstacle prefab into the variable. So let me do that really quick. Cool. So now when I press play, now, oh, there you go. So we have 2. And I wonder if 2 are just going to fly at us randomly from the screen. Perfect. So since we're spawning one of our obstacles through code, we don't actually really need this obstacle anymore. That's just about everything it's going to do. And we're not editing a massive amount, so we'll just remove that. So then that way when we press play, it spawns one and it flies at us. Cool. So now what you're going to do is create your own empty game object in your project hierarchy. Call it spawn manager. And then in your scripts, you're going to make a spawn manager script. You're going Cool. So now when we press play, our spawn manager spawns one of our obstacles, but we do need it to spawn more obstacles, so that way it's more like a game. So in our spawn manager script, we're going to set it so that we can actually create all of these obstacles at intervals again. So first what we're going to do is we're going to create another custom script so that we can spawn these obstacles. So we'll call this void spawn obstacle. Make sure you put parentheses, enter, create those curly brackets, and then we already have a line of code to create a new obstacle. So we're just going to take this entire line and we're going to cut it and paste it into spawn obstacle. Now we're going to reuse that method that we used before called invoke repeating. That's not in the right place at all. That's better. So invoke repeating we'll use to constantly call our spawn obstacle method over time. So we're going to use the name of our method, which is spawn obstacle. And we're going to give it a time to start at. So in this case, we'll just call this start delay so that we give our player a little bit of time. And then we're going to give it a rate that it's going to constantly repeat at. So we'll just call this repeat rate. And then our computer's mad at us because we actually haven't created those variables. So we'll do a private float for the start delay, since we know that 2 is generally a good number to start at. So we don't really need to change that one around. And then for the repeat rate, we'll just change this in code if we need to. So private float repeat rate. And we'll just have a repeat every 2 seconds as well. Now, if I go back into Unity, you can see that eventually we have these obstacles that spawn, and they fly very fast. Probably change that later. Oh, and then there our player goes. Now, one thing that you might notice, aside from all of the obstacles that are just flying away in the distance, is that at some point our player starts to lean over, and that looks kind of weird. A really cool thing that you can do, especially with rigid bodies, is you can see under all of these different options for our rigid body, there's actually constraints. So if we actually open up constraints, we don't actually want our player to be able to turn or move in any other direction except the Y. So we're actually going to just freeze the position of the X and the Z, as well as freeze the rotation of the X and the Z. And really, we actually only want the player to go up and down, so that's just the Y position, so we'll just freeze the rotation of the Y too. So now, whenever the player gets hit by an obstacle, they won't turn side to side, they'll just constantly only be able to move up or down. So, if we press play, and then if I try and avoid these obstacles as best as I can, and I just jumped over that one, and so then let's see what happens if we run into one. Cool, and just get hit by the obstacle. Nothing happens other than that. I don't get these weird tilts that happen or anything like that, so perfect. That's exactly what we're looking for. So now what you're going to do is create your own variables inside Spawn Manager for the start delay and the repeat rate. You're going to take your instantiate method from start, and you're going to create a new custom method called spawn obstacle. So then that way you can just call spawn obstacle whenever you need to create a new obstacle. And then we're going to reuse that invoke repeating method that we had before so that we can constantly call spawn obstacle, and it won't start until 2 seconds, and then it'll repeat every 2 seconds afterwards. And then last but not least, you're going to use rigid body constraints to actually freeze everything except the Y position, so that way the player can only move up or down whenever they jump. Now it's your turn.
Okay, well, I guess I'm done with that one. We move on to the next part. Clear instructions is good enough. Make the world whiz by, so we're going to learn how to loop the world. Loop to the background. What were you saying? You spent $15 on a mobile game? I play Genshin Impact, and I don't spend money on that. And that's like almost a normal game that just happens to have mobile features in it. I don't know how you can spend real dollars on a mobile game. Your gambling addiction has to stop at some point. Maybe someday. Maybe someday. But we have an Endless Runner to make, which is not a mobile game at all. This is a completely legitimate game. It just happens to be an Endless Runner, which most Endless Runners happen to be mobile games. But that's fine. Anyway, let's move on.
Being a programmer is a lot like being a magician. Since you control exactly what the user sees, you can do things behind the scenes to create amazing illusions. And that's exactly what we're going to do to make it look like the character is running through an endless world. What will actually happen behind the scenes in scene view is that the background object will move left, then reset, then move to the left again, and then reset. Endlessly, seamlessly, magically. By the end of this lesson, the background will scroll endlessly, but as soon as a player hits an obstacle, everything will stop. If you take a look at one of the backgrounds, you'll notice that it's actually two of the exact same image repeated twice. So what we'll do is get the width of one of those repeating sections, and as soon as the background has moved that distance, we'll reset it to its starting position. And the player will be none the wiser. As soon as we figure out how to get the background to repeat, we have to figure out how to make it stop when the player hits an obstacle. Here's the tricky part. The code that detects when the player hits an obstacle is in the player controller's script, and the code that controls the background is in the repeat background script. Somehow, the repeat background script needs to know when something happens in the player controller script. That way, when the player controller script detects when the player has run into the obstacle, the repeat background script can stop. We'll have to figure out how to make these two scripts talk to each other, how to communicate. We'll have to learn the ancient art of script communication. And to make all that happen, I'll see you in Unity.
Okay, cool. So we have our little character here, happily jumping along through the forest, and occasionally that obstacle comes through. But we do have a larger problem where, because we're making it look like the character's running through the woods, in fact, it's our background that's running away from our character. So we need to figure out a way that we can actually fix that. And I have a little bit of an idea. So one thing that I could do is actually, if I select our background and I Control D to duplicate, I can create another background, and then I can just keep creating these backgrounds over and over again, and then it'll just look like the player's running through. However, that's probably one of the worst ways that I could actually solve this problem, because then I'll just have maybe like 50 or 100 of these backgrounds that are just constantly moving all across the player, and eventually they do run out, so I can't actually make that infinite, and it'll actually create some big problems for making sure that our game plays well as it's trying to render all of these different scenes that are moving through the scene. So, another option is if we delete this background, because I don't think that solution's a very good idea at all. Another way that we can think about this problem is we actually have this background here, and if you look at the halfway point, just about there, you can see that the background actually repeats itself. So it's got the same trees, and it's got the same rocks at the end. So we already have our own little repeating background, and actually we can think of the problem in this way, where if you take a look at the player screen, as we move the background over, just about at this point here, it looks like the background is exactly the same. And so what we can do is precisely at this point, we can actually just reset our background, and it will look like the player is constantly running through an endless background when in fact it's just these two images next to each other, and we're just constantly putting it overlapping each other every single time we want it to look like the player's running. So we're going to try and do it that way instead. We're going to need a script in order to do so. So we're going to right-click on our scripts folder, create a C# script, and we'll call this repeat background in order to repeat our background. And now with this script, we're going to drag it and drop it onto our background object. And then we're going to make sure that it's applied. So now you're going to go into your scripts folder, make a repeat background script, and then you're going to apply that. Cool, so we've taken our first steps in fixing this problem that we created for ourselves by making this background move to the left until it disappears. So we have our repeat background script, so we're going to go into that script by double-clicking. Now, in our repeat background script, we're going to create a variable for ourselves to make things a bit easier. So this will be a private variable, so we can just change it in our code if we need to later. It'll be a vector3 because we actually want the position. And in this case, we're actually going to be getting the position that our object starts at. Now, this will be very helpful so that we know where we should reset our background when it reaches the point that we need to put it back and make it look like it's repeating. Now what we're going to do is actually in our start method, we're going to set our start position, and we're actually just going to get all of the coordinates of our transform position. And now we need to check to make sure that whenever we get to a certain position, we can reset our background to go back to our start position. So we're going to use an if statement to do that check. Now we're going to want to find the current position of our background. So we're going to use our transform position. And since our background is only moving on the x-axis, that's the only position we actually need to check against. Now we want to see whenever our current position becomes less than our starting position. But specifically, we want to make sure that our background is farther down the line on our x-axis before we reset the position of our background to be the starting position again. So we'll just use an offset for now, and we're just going to use like 40, I think. We'll see how that works. And then if we create a new line, and then we use the curly braces, in our if statement, we're going to set our transform position that it's currently at, and we're just going to reset it back to the position of our variable. Now, in Unity, we'll see how this works and how this looks. So, whenever our current position hits a certain point past the start position, it'll reset itself. So that looks kind of okay. It looks a little weird. It kind of looks like the background is stuttering in some ways. Let's see if we can fiddle with that number just a little bit more. Maybe we'll set it to like 50 so it's farther down the line. So we'll change the variable to 50. And we'll save that, and then we'll see how that looks. So now, hopefully our background can go a little bit farther down before it resets itself. And it looks a little bit better. It's getting almost there, but I think that's good enough for now. So what we'll do is, in your repeat background script, you're going to create your own variable for a coordinate. So you're going to use a vector3, and that coordinate's going to be your start position of your object. In the start method, we're going to set the start position equal to the Alright, so we've made it so that our background repeats every time it goes back through, but it does look a little bit weird. It's not exactly perfect. You can definitely tell that something's wrong here, but at least our player jumps and they're still happy, so that's good. So in order to make our background transition seamlessly back and forth, we're going to use some new variables to be able to do so. But first what we want to do is we're actually going to use one of our box colliders to help us with this problem. So on our background, we're going to add a component, and then we're going to look for a box collider. And now you see that our box collider wraps entirely around our background, which is perfect, because once again, that means that there's less that I have to do myself to wrap that box collider. And you can see on our box collider in our inspector, it actually has a size. And that is extremely helpful because now we no longer need to guess what the halfway point is of our background. So now, in our repeat background script, we're going to use another variable, and this one will be private since we know exactly what we need now. And it'll be a float since you saw the size had some decimals in there. And we're just going to call it the repeat width. And so this will be the width that we actually repeat at when we want to reset our position. In our start method, we're actually going to set our repeat width. So we'll use repeat width. And we're going to set this to the size of our box collider. Now, because our box collider is a component, we're actually going to need that getComponent method again. So we're going to getComponent. And now we need that left and right caret so that we can get the type of component we're looking for. So in this case, we're looking for a box collider. And then we're going to use our parentheses since this is a method. So now we're getting the box collider on our object. And what we want to do is we can actually get the size property of that component. So if we type in size, and then we get the actual X size, so then we can get the total width of our background. And we're just looking for that exact halfway point. So we'll divide using one right forward slash by 2. And that'll give us half the size, half the width of our background. And then last but not least, the only thing we need to do is get rid of this hard-coded number right here. And this will be our repeat width. So now when we save, now that we're back in Unity, you can watch as our happy little player runs through the scene, and it looks like even though you can see the scene moving back and forth in order to make it look like it's repeating, in the player's view, it looks exactly perfect. So, now it's your turn. So, what you're going to do is you're going to apply a box collider on your background, and then so our game's looking really good now. So we have the background that scrolls endlessly. We have our happy player who jumps through the forest as they're avoiding all these obstacles. And now what we want to do is we want to actually make it so that we can end our game and send it to a game over screen. So what we're going to do is we need to figure out how we can actually label all of these different objects so that whenever our player collides with them, we know what we've hit. One really cool way of doing this is by using something called tags. So if you look at the top right of our inspector, we have our ground selected, and there's this little button called tag. And what we can actually do is create different tags for different things. So we could actually go and tag our player as player, tag our main camera as our main camera. We can tag locations, different things like that. So we'll actually create our own tag by clicking Add Tag under that dropdown. And you'll see that there's a tag here that says List is empty. So this is our list of tags that we can use that we created. We haven't made any yet, so we'll actually go to this little plus sign on the bottom right of this bar. And we'll click that and we'll add our own tag. So we'll call this one ground. And then we can press enter to save. And now when we go back to our ground, oh, that's weird. So what you actually have to do is you go to the tags in your inspector, you click the drop down, and it brings up all the different tags, and then you select the tag that you want to use. So it doesn't, unfortunately, automatically tag something when you create the tag. So you just have to make sure you go back into whatever you want to tag and apply the appropriate one. We're going to do the same thing to our obstacles, but in this case, since we have prefabs, we need to double click on our obstacles or click on the obstacle and click open prefab. And then you can see we have another tag here. So we'll go to click it and it's untagged right now. So we'll add a tag and we already have our ground tag, but we want a new tag. So we'll create another one and we'll call this one obstacle. Now, if we go back to our hierarchy that shows us our prefab preview, you can see the obstacle here, so if we click that, and then under tags, just make sure that you go and tag it obstacle. And then when we leave our prefab editor, by using the arrow next to the obstacle underneath our hierarchy, now whenever we create obstacles, it'll have this tag applied to it that says obstacle. So now we need an actual way to interact with these obstacles. So we're actually just going to use our player controller script. And then in our player controller script, you can see that we actually already have a way to detect collisions. In this case, we're detecting a collision on the ground. So in our player controller class, this is actually where we'll just store the state of our game over. So we'll just make a public Boolean for now. So that way we can see when our Boolean is true or false. And we'll name this game over. So now we have our game over state saved. And we're actually going down and you can see that we conveniently already have a way to track collisions against other things using our onCollisionEnter method. So this is actually the place where we can compare the different tags whenever we run into those objects specifically. So we'll start actually with the ground since we already have this variable here. So if, and then our condition, we're going to use collision because in this case, the collision is actually the object that we're colliding with. And then we're going to call that collision's game object. And on that game object, we can compare the current tag that it has. And we can actually use a string for that tag, so we named our ground ground. Now, in our statement, we can specifically check when we collide with a certain game object, we can check that game object's tag and see if it's ground. So now, we'll take our isOnGround variable, and this is where we set it to true. And now, after we've compared for the collision of the ground, we can actually compare for the collision of our obstacle. So we'll actually use an else statement. So else, if what we're colliding with is an obstacle, then we'll do this thing. So we'll check first if we're colliding with the ground. Otherwise, if what we're colliding with is an obstacle, we'll do this. So we can use a debug.log statement so that we can see in the editor in Unity when our game is over. And then we have that handy game over Boolean at the top. So Since its default value is false, now we set game over to true. So, when we go back into Unity, when we play our game, you should see on the bottom left that game over pops up and tells us that we ran into an obstacle. So we'll just wait for one of these fun obstacles, and there's one. Ooh, missed it. My farmer's just so excited. And then we'll hit this one, and boom, you can see there's a game over at the bottom.
Well, so far this one is interesting about what it's teaching. And yeah, no more anything. No more anything, Jordan. You don't get anything. My body feels too tired from exercise. Okay, so I want game over equal true. And then debug log game over. Okay. So when we collide with that, it'll say that's not right. Okay, so that's interesting that tags are used in that way. I wasn't sure how those are going to be used. I kind of figure, but I guess that's a way to reference an object. So I wonder if you can tag scripts then. Is that the way that you do it? Can you just tag a whole entire script? The script doesn't have a tag. You can tag an object with a script on it though. That might be done differently. Either way, hit play. We can go to our console. Oh. Did I do it wrong? Not showing it. Did I do something wrong? What did I do wrong? Oh. For some reason I made this ground also. It should be obstacle. Let me make sure I spelled that right. Now I realized what I did. WSTACLE. Don't know, I'm so bad at spelling the word obstacle. Okay. Now it should show it properly. So we jumped over that. Now we hit that, and we get our debug log to come up. Game over appears there. So then if we keep hitting it, we get more game overs. It's updating the time, millisecond stuff. Too bad it doesn't keep updating the log more, but that's not a big deal. Okay. So we got all that. We got a stop move left on game over. So this one might be a bit more in depth. We'll see.
Cool, so we have our character in the scene, and whenever we run into one of the obstacles, but right now he's so happy we just missed one, and we hit one of them, and you can see game over pops up at the bottom. Now, we actually want to be able to do things when we end our game. So one of the things that we'll do is we'll make it so that the background stops scrolling and the obstacles stop when the game is over. To do that, we'll actually need to do some communications between our scripts to be able to know when to stop the game. Now, in our move left script, how exactly are we going to know what's happening in our player controller script? Well, for now, we'll create a variable so that we can hold a reference to our script. So, specifically because our player controller script is a class called player controller, we actually just call player controller. Now, this is very similar to how you would just call game objects, but in this case, we're just calling a player controller. And we'll name this player controller script. And although not very creative, is very descriptive, which is incredibly helpful. Now, in our start method, this is actually how we're going to connect our reference to our script to the actual player controller script in our game. So we're going to use our player controller script, and we're going to set this to the player controller script on our player. So we can actually use the game object class, and in our game, we're going to find the name of our object, which in this case in our game is called player. So this will find player in the scene hierarchy. And now that we've found our player, we can actually get their component. And we're looking for specifically their player controller object, which we put inside the left and right carets. And then since this is a method, we make sure that we put our parentheses. So now this is how we can set our player controller script to be the actual player controller script in our game by using the player in our scene. And now in our update method, we can actually stop things from moving whenever we collide with that player and the game over condition happens. So if player controller script, since we now have that reference, and we want to check whenever the game is over. However, in this case, we're looking to move things when the game is not over. So if game over is equal to false, we use those two equal signs to say that it's equal to instead of setting game over to false. And then we use our curly brackets and then press enter, and we can actually just cut this entire translate method and put it inside this if statement. One very important thing to note is that you can see that we can very easily get our game over variable from our player controller script. Now, if this was a private variable, in fact, we wouldn't be able to see this at all. Now, if game over were a private variable, we wouldn't be able to see this at all. Just like public variables can be seen in the Unity editor and private variables cannot, public variables can be seen in other classes while private variables cannot. So if I were to get a move left script somewhere and I wanted to get the speed variable, I would have no way of doing that. If I made the game over variable private inside of our player controller script, I would have no way of seeing this variable and being able to know if it was true or false. So now, if our game over is false, if our game is not over, then we're just going to keep moving things to the left. So if we save in Unity, now this time, when we play the game and our player runs into one of the obstacles, everything stops. And we're still jumping for joy, so excited. And you can see all of these obstacles just spawning on each other, and there's not enough space. Now what you're going to do is in your move left script, you're going to get a reference of our player controller script on our player by creating your own player controller variable. In our start method, you're going to set that variable to the player controller object or component on our player game object in our scene. And then, whenever the game is not over, we're going to make sure that all of our obstacles and our background keeps moving until our game over happens. Now it's your turn. Cool, so we have all the right steps to make our game end. So when we hit one of the obstacles coming into the scene, everything stops. However, you can see this problem where we just have this infinite number of obstacles being created non-stop. Let's see how many we can pile on. I don't actually want to see that. So what we're going to do is we're going to fix that small problem just because we don't want to keep creating all these obstacles in the scene. We just want it to stop entirely. So that way our game doesn't just slow down to a standstill because there's 1,000 of these little obstacles all the way over here that you can't see. So we're going to go to our spawn manager script, and using the same thing that we just did in our move left script, we're just going to get another reference to our player controller script. So if we make another private player controller, and we'll call this player controller script. Now in our start method, we're going to attach our variable to the reference of our player controller script in the scene. So we player controller script, we're going to set that to a game object that we're going to find in our scene, which happens to be called player. And then in player, we're going to find the component, which is our player controller. Now, in order to stop spawning our obstacles, now that we have a reference to our player, we're actually going to check for when the game's over inside of our spawn obstacle method. So if we use an if statement, if our player controller script game over boolean is false, then we can just cut this little bit out and paste it in our if statement. So now when our game over is false, it'll keep creating all of these objects. However, when our game is over, then it stops creating these objects. Now, if we save that and we double check in Unity, you can see that our player hits our obstacle and none of the obstacles are magically spawning, which is great. So now it's your turn. In your spawn manager script, you're going to create another player controller variable. In the start method, you're going to set the player controller script variable to the player controller script of our player object in our scene. And then to stop spawning any of these obstacles, in our spawn obstacle method, we're actually going to check when the game is not over to keep creating these obstacles. Otherwise, when the game is over, it'll skip over this line of code and it won't create any more obstacles. Now it's your turn.
I feel like I should probably write down that you can do the game object find thing. That seems very useful. What else would be good to mention? Leave an object as equal false instead of, normal false. It has to be equal false. Well, either way, we did all this code stuff, so like they said, when it game overs, we should see it not spawn anything else then. So we can see over on our hierarchy that it's not spawning anything else. Probably save that. Hierarchy. Hierarchy. Hierarchy reference. What it's referencing. How did I use the tags? It was compare, right? The hell line of code is it? Is it capitals? Yeah. It's not an S though. Compare tag. And it's name of tag. Okay. Got that stuff, got that. Let's keep moving on.
So we're almost there with the mechanics of our project, but we do have one last small problem to deal with, which is whenever we jump over one of our obstacles, you can see that they just fly off into the distance forever, and so we actually need to get rid of them because otherwise they'll just keep creating obstacles, and then it might slow our game down. To do that, we're going to go into our move left script, and now in our move left script is a good place where we can keep track of our obstacle and then remove it from the screen whenever it goes off the player's view. So in our update method, we're going to use another if statement, and we're going to get our current object's transform, position, x. So that way we can see when the position goes past the edge of what we can see. And for now, we're just going to set it to something like -10, and we'll just see, and if that works, then we can turn it into a variable. And then we'll write the thing that we want it to do when this happens. So when our object goes past -10, we're going to destroy our game object. Perfect. Now let's see how this works. So now if we watch our obstacles in our scene, we should see them get removed whenever they go past the end. Uh-oh, I broke something. On the upside, the obstacles delete at just about the right place. Maybe we'll set it to like -15. Let's see, what did we do wrong? I see. So we didn't use that tag system that we had set up, and so it's just deleting anything that goes past this point that's using the move left script. So since our background is using move left, since the background went past -10, it deleted itself. Not that big of a problem, so we'll just make sure we take the current game object and we'll just get the tag that's on it, and we'll make sure that it's an obstacle. And then we have this -10, so we're just going to make this the left bound, since this is the left boundary of what we're hitting. And then our computer's mad at us because this doesn't actually exist yet, so we'll make this variable. Since we already know the number that we want to set it to, so we'll make it a private float left bound, and we'll just set this to -15. And so now when we save, and then we go back into Unity, when we play, hopefully our background doesn't delete itself. Cool, so our background's still going, and we have the obstacles delete themselves. So, perfect. Now we have all of the mechanics that we need. So now what you're going to do is, in your move left script, you're going to create your own variable for the left boundary. And we're going to go into our update method and create a new if statement. So we're going to compare our game object's current position to see when it goes past the left boundary on the left side, and make sure that it's an obstacle instead of just deleting our background as well. So when it's both past the left side of our screen and the thing that's moving is an obstacle, then we'll destroy that game object. Now it's your turn.
I did something wrong. I did something wrong. What did I do wrong? What? I'm done. I didn't have an extra parentheses there. That was the issue. Well, anyway, now we jump over objects. They should get destroyed when we jump over it. They don't spawn when we fail, when we get the game over. And they get destroyed immediately when we jump over them. So those don't stay in the scene to make it load all slow. Yeah, you can see it destroyed there when we do that. So that's nice. We got all that going well then. I think that's the end of this section anyway. So there we go. We figured out all this. Equal to operator is what it says. Is the equal? I have no idea what an operator is. But I'll write it down anyway. Okay, clear instructions. But do I understand it? No. But I'm doing the tutorial. Balloons, bombs, and bullions. Or the player's animation. Make the player start off at a run. Set up a jump animation. Just the jump animation. Set up a falling animation. Keep the player from unconscious jumping. Okay, so this is our animation part. Let's get into it.
We have successfully created the illusion that the player is moving at high speed through the scene. But let me ask you something. How on earth is he going so fast without moving his legs? How is he jumping without bending his knees? And how does he remain so calm after crashing into that fence? These are very difficult questions indeed. But luckily, we won't have to answer them. Because by the end of this lesson, your character will have incredible animations for running, jumping, and even being knocked unconscious. To pull this off, we will have to become very familiar with something called an animation controller. You may not be surprised to learn that an animation controller is something that controls a character's animations. It is a weird diagram looking thing with boxes representing various states that the player can be in, like running or jumping, each of which has a unique animation. There are also transitions between each of these states where, for example, the player can go from running to jumping or from standing to dying. So in our player controller script, we just need to program the if statements that will control when the character transitions from one state to another. For example, if the player presses spacebar, then transition from a running state to a jumping state. Or if the player runs into an obstacle, then transition from a running state to a dying state. Well, to make all that happen, I'll see you in Unity.
Cool, so we've got a lot of awesome functionality in our game now, so you can see the player jumping because they're so excited, and you see all these obstacles moving through the scene. Now, the one thing that you notice is that the player is standing incredibly still. Now, that's either because of one of two reasons. Either the player is moving so slow that they're not actually moving at all, or the player's moving so fast that our eyes can't even perceive how fast the player's moving, and so we can only see it as standing still. I'll leave that up to your own interpretation. So in order to actually make the player look like they're moving in the scene that's constantly moving back and forth, we're going to need to play with the player's animation. So what we're going to do is we're actually going to click on the player, and then in their inspector, you can see that there's actually an animator component already applied to it, and it has a controller for a simple character. So what we can do is we can actually double click on that simple character box, and now you see that it actually opens up a brand new window in our scene for animators. Now, if you want to see all of the different windows that you could actually add to Unity, you can actually see on the top left, there's the window button, and then you can actually add a bunch of other windows that you can use. One that you might have seen before, actually our console, is where the game over message is being sent. So you can add other windows if you want to. So now in our animator window, you can see that we have a strange view of this button that says entry, but not really anything else. You can actually move around in this view. There's a lot more going on. So we can press the Alt key and hold it and then left click and drag, and we can move around our little animator window here. Or we can use our mouse wheel and scroll in and out to zoom in and out. And if you click on your mouse wheel and hold, and then you drag it around, you can actually move around that way. So there's a lot of different things happening in our little animator window here. Now, first and foremost, the animator controller is the way that we actually control the states that the character is in at the current moment. So, in fact, when we're pressing play, our animator controller goes straight to our idle animation, which is why it looks like the player is not moving at all. So the player's not moving. Surprise, they're not moving incredibly fast, they're just not moving at all. So our animator controller actually controls all of the different states that our character can be in. So our character can be idle, and then from idle, these arrows actually mean that they then can go into one of these different states. So it can go from idle into a walking static state, which means that they're not actually walking in a direction, they're just walking in place. You can also run in place with run static. You can walk in a direction using walk, or you can run in a direction. And so if you started to move, for example, maybe it'll go to the walk animation, and then when you stop moving, it'll go back to your idle animation, so you stand still. Now, a really cool thing is you can actually see what these different animations are like. So if we zoom in a little bit, if we were to double click on idle, you can actually see that it pops up a little animation preview, and we can actually press play, and you can see that the model isn't actually really doing anything. You can see it's just kind of waving its arms back and forth. If we choose, for example, walk static, double click on that, we have another animation. And so you can see it actually looks like this character is walking, which is cool. If we double click on run and we press play, you can see that this one is actually moving through the scene compared to if we go to run static, this one runs in place. So very helpful to know the states of all of these things. If we take a look at the arrows, you can actually see all of the different conditions that need to happen to actually make the character move, which we'll go into a little bit on how we can edit those and see those. So you can see we have these conditions for an actual speed. So say the player is not moving, their speed is 0. And then they start moving and it reaches a point where it's 0.25. Then it will actually go into this transition, and you can see this transition happen. So they're stopped, and then they start moving, and then it goes into walk static, and the player is just moving. So now what you're going to do is you're going to left click on the player in the hierarchy, and then under the inspector in the animator component where you see controller, you're going to double click on simple character. This will open up your animator window for your player character. And so now you can go look around and see all of the different animation states. You can click into the different states by double-clicking on them. And then you can preview their different animations like walking static or walking. And then you can take a look at some of the different transitions and see the different conditions that they need to follow to be able to move. Now it's your turn. So we've gotten to move around our animator window just a little bit, and we've gotten to go and look into some of the animations themselves and preview them. And we've seen some of the movement between all the transitions. So now what we're going to do is we're actually going to play around with the values in these transitions. So knowing that our transition for our speed needs to be greater than 0.25 to be able to start this walk static animation, we can actually go over on the left side of the animator window to parameters. And if we click this tab, we have a parameters section that opens. And here you can actually see the parameter of the speed that we can set. So in fact, if we make this, for example, 0.3, because 0.3 is greater than 0.25, and now when we press play in our game, we can actually see when the player enters the game, then it should go into the idle state, and then it'll go down to the walk static state. So we're in idle, and then it starts walking. Now, it looks a little weird because the background is moving incredibly fast compared to the actual player. So let's see what kind of speed that we need to have. We need greater than 0.5. So we'll make this like, we'll just make this 1. So it's definitely more than 0.5. So we press play. There you go. And then you can see it goes from the walking to the running animation. Now that does look kind of weird because the scene is just moving. So we can actually set a default animation state. So if we go to our run static here, and we right click on it, we can actually set as layer default state. So if we select that, you can see our entry state goes directly to our run static instead of to idle, because from idle we had to go to walk static all the way to run static, and that just took way too long. So now when we press play, you can see that the player starts running. The animation's still a little too slow, but we can fix that really easily. So you can see on our different states, there's actually some information in the inspector. So you can see actually the speed of which the animation runs. So since the player looked like they were running a little slow comparatively, we'll set this to something like 1.5. And now we'll play this animation. And there you go. Now it looks like the player's really running, and then they jump, and they're still running, but that's fine. We can fix that at some point. Now they're just moving so fast that they just end up back in the same place on Earth. And then one more thing that you can see is you can actually see different animation layers, which we'll go into, but it's just kind of interesting to see how they all work. So with the idle, you can see all of these different idle states that it can go into. With jumping, you can go from idle to a standing jump or walk and then walking jump. There's different ways of dying or crouching. So there's all of these different kinds of animation states that we can control based on certain conditions. So what you're going to do is you're going to start using some animations of your own. So make sure that you click on the player in the hierarchy. In their animator component, you're going to double click on the controller, which will then open up your Cool. So we've got it so that our player looks really good while they're running through the scene. But we do have another weird thing where it's pretty awkward that they're still running while they're jumping. Unless you're in like an action movie. That's not really something that people usually do. So we're going to do some things to the jumping animation to really make it look real. In fact, we're actually going to use our player controller script to be able to do that. So if we go to our assets, and we can just close off the source files, collapse them because it opened it up when we opened the animation controller. And now if we open our player controller script, now in our player controller script, we're actually going to get a reference this time to our animator. So similar to how we got a reference to our rigid body, we're going to get a reference to our animator. So we'll also make this private because we don't need to find this outside of our class. It'll be of type animator, not animation. And we'll just call this player anim for now, for player animation. Now, just like our rigid body, we actually need to get the actual component on our object. So player anim is set to our get component. And what component are we getting? Our animator. And then make sure to call the method and close your statement. Now, in our update function is actually where we want this animation to happen, but what animation exactly are we trying to make happen? Well, let's see. In Unity, if we go to our animator and we find our player animator, now if we take a look at our layers again, you can see that we have all of our different layers and we want our player to jump. So we'll go to our jumping layer and we're going to center all of our animation states. Now we have one that goes from run to running jump. Now how do we get there? Interesting. So you can see to get from run, under our conditions, there's something called a jump trig. So let's see if in our parameters, so we do have something called a jump trig that we would be able to use. Now, if we follow the naming of all of these different variables, so you can see we have speed underscore f, and it has all of these decimals next to all of them, so that must be a float. And under animation int, so that's an integer, they're whole numbers. Under our static b, crouch b, so since they're checkboxes, they're probably booleans. So I think our jump trig is probably actually a trigger that you could think very similarly like the triggers on our colliders. So in our player controller script, so we have this place where we make this jump actually happen. So let's see. So if we use our player animator, let's take a look at some of the methods. Wow, that's super convenient. Dot set trigger. Set the value of the given trigger parameter. And it's got an overload. Well, let's see. That seems like something that we want to use. So we'll use set trigger. That way we can use our jump trig. Let's see. Maybe, what's the other option? Oh, I can just use the name. So if we set this to be, I believe it was spelled like so. Now, this set trigger method should activate our jump trigger when we press the space bar, since it's inside our if statement. Well, let's give it a try. Let's see what happens. So if we play our game and we jump, oh my gosh, that was a little weird, but we have the jumping animation. Well, that's cool. It kind of looks like it's like Superman or something. Superhero. Alright, so to get started activating these animations, what we're going to do is in our player controller class, make sure that you add your own animator variable. And then in the start method, make sure that you assign your animator variable to the animator component, and then in our update method, where the player actually jumps, great. Now our player character animations are in a really good place. We have our running animations, and then when we jump, you can see we jump for joy, but we have this weird little issue where when we jump, the animation stops short, and then we start running in the air, which doesn't really look right. So we're actually going to go into our running jump animation, and similarly to how we set the speed to be a little bit faster for the run to just make it look like the player's running faster, we're going to set our animation speed just a bit slower. We'll do 0.7, just so that the animation now runs just a bit longer instead of faster. So when we press play, now when we jump, the animation definitely works a lot better. It lasts a bit longer. I think one thing that we're going to do just to make it look a little bit more realistic is we're actually going to go into our player object, and we're going to play around with some of the variables, so specifically our mass, our jump force, and our gravity modifier to just make it look a lot more realistic and better for what we want to be. So our mass on our rigid body is a little low. People don't normally weigh just 1 kilogram, so we're going to change our mass. Usually on average a person weighs about 60 kilograms or so. So we'll see what that does when we press play. And we have the jumping animation, but we don't really go anywhere. So let's play around with the jump force a little bit. Maybe let's set it to a little bit over like 10 times the actual mass. So we'll do like a 700. We'll see how that looks. Ooh, I go a little bit high. So maybe, let's see. If we go to our gravity modifier, let's make it a little bit more. Let's make it like a 1.5. And now when we jump, not bad. Pretty close. So we could probably fiddle with these values a bit more, but it looks pretty good. We get pretty close to the ground before we start running. So now what you're going to do is in your player animator window, if you go to the jumping layer, and then we click on the running jump, so we'll set the animation speed to be a little bit slower, so I set mine to 0.7. And then on our player object, we're going to make the player weigh a bit more, so let's make it about 60 or so kilograms. We pushed up the jump force up to 700, and then we increased gravity just a little bit, so we set it to about 1.5 so the player falls a little bit faster when they reach the ground. Now it's your turn. Cool, so we've hit the ground running now. We have our running animation set up, we have a jumping animation so we can fly through the air, so excited. Now we just need to add one more thing, which is whenever we collide with one of these barriers, we're not just going to keep running into one of the barriers. So what we can do is we can use one of our other layers for character deaths. Now, in our deaths layer, you can see all of the different kinds of states that they can go through. So we can go from alive to a death 1. So let's see if we double click that, and we'll play that, see how that looks. Falls over, and then death 1 is just the character falling over. Death 2, what does this one look like? Falls over in front, so falling over front doesn't really make any sense in this case, so we'll probably just go with death 1. Now, let's see how we can actually make this death animation play when it happens. So, let's see the transitions here. So, let's see, the conditions are, so the death bool should be set to true, and there's a death type integer that's equal to 1. So, as a good way to kind of manage the state, we can actually see the second transition, and you can see death type becomes equal to 2 in that case. So, since we want the first death animation, that's the one that we'll go with. So if we go into our scripts again, all the way down at the bottom here, go to our player controller script. So now in our player controller script, we're going to go to the place where we end the game, where we have that game over bit of code. So down in our on collision enter, you can see if we collide with an obstacle, then the game is over. So this seems like a pretty good place where we can actually make this death animation occur. So let's see what kind of methods we have for our player animator. So let's see. So we had set trigger to set a trigger. Now that death B was a bool, so can we set bool? Oh, cool, perfect. So we'll set bool. And we wanted the death bool to be true, so let's see, we can use an int ID, or we can use the string name. So I believe the name was capital D F underscore B for the bool, and then the value that we want to set it to. So in this case, we set it to true. Cool, so now we set death to true, but we need to actually make sure that we select the proper death type. So let's see if we can actually set that to. So player, anim, and then let's see, it's dot, so it was an integer, so cool. So there's a set integer option too, so we'll select that one. And I believe can probably use a string again. Just double check. String name. So then it was, I believe it was a capital D, F, capital T, type, and then an underscore int. And then I believe the one that we wanted was the first one. So 1. So now if we save, so hopefully if we typed everything properly and we set the proper values, it should, when we go into our game. Cool, so when we play, let's see what happens when we run into the obstacle. Let's wait for one of them to spawn. Boop. Oh, there they go, and falls over, and then it goes into the dead state in our animation. So, perfect. So, now what you're going to do to add in this animation is in your player controller script, in our onCollisionEnter method, where we actually collide with an obstacle to end our game, that's where we're going to use our player animator variable. And we're going to set the animation to be our death B. And since our death B is a Boolean, we use set bool to set it to true. For our death type, because it's an integer, we set it with integer, and we'll set that one to 1. So then when we go play the game, you can watch as the animator window transitions when the player hits one of the obstacles. Now it's your turn. Cool, so we've set it up so that when our player runs into an obstacle, it'll start the death animation. But there is one small problem that we actually need to fix, which is when we press the space bar, we're actually still able to jump, and that's definitely not something that should be possible. So we're going to need to change our code just a little bit so that way we don't just magically jump even though technically the game is over and the player has died. Now, in order to prevent our player from jumping over and over again when the game is over and they've lost, we'll actually need to change the condition of our if statement. So, perfectly fine that they press spacebar and they can jump, and to make sure that they are on the ground when they jump, but we do need to make sure that the game is not over, otherwise they'll still be able to jump when the game is over. So, we're going to add an and symbol here, so 2 ampersands for and then we're going to use if game over equals false. So if the game is not over, then this thing will run. In fact, there's actually an easier way that we can do this. So we can actually use what's called an exclamation point and set this to true. So in this case, the exclamation point actually negates the statement after it. So if game over is not equal to true, so the same thing as saying game over equals false, then it will do this thing. In fact, there's actually even a shorter way that we can write if the game is not over. For Boolean values, we can actually just put that exclamation point in front of game over. So in this case, this says, if the game is not over because of this exclamation point, then do these lines of code. Now if I save, we can see if this code really worked when we press play. So if we press space, we can still jump, and then if we hit one of the barriers, the player runs into it, and then we press the space bar and we can't jump anymore. So, a really easy way that we can prevent the player from jumping after the game is over. So, what you're going to do is in your update method in the player controller, you're going to add in your if statement another and comparison so you can chain them all together. So, if the space bar is down and the player is on the ground and the game is not over, so all of these have to be true, then this will happen. Now it's your turn.
Oh, well, more steps going through. Our running simulator is a running simulator. Our endless runner is shaping up. I like how this section is supposed to be audio, but so far we haven't done any audio. It looks like that is going to be this section now, though. So we'll see how that does. I'm curious to see where this goes. This has a lot to it. Definitely has several things in it. We do unit 3, 4, and 5, and then we have a bunch of like not practical things. All of the big boy not fun words. Rifled off. Blah, blah, blah. Let's see. It should be fine. Probably.
We added a lot of polish to this prototype when we implemented those animations, but if you really want a polished product, you need two things: sound effects and particle effects. Don't believe me? Just compare this to this. That second one, that's what we want. Well, by the end of this lesson, your prototype will have background music, it'll have particles flying up behind the character's feet, a jumping sound effect, and an incredible explosion when the player collides with an object. Programming particle effects is pretty straightforward. You just attach a particle effect to the player, and then decide when to play and when to pause them. Sound, on the other hand, is slightly different. Because you're working in a 3D environment, sound in Unity works just like it does in the real world. You have audio sources that create sound, kind of like a speaker, and you have audio listeners that detect sound, kind of like your ears. What the audio listener hears is what the player will hear. We just have to program the audio sources to play sound so that the audio listener can hear it. And to make all that happen, I'll see you in Unity.
Alright, so we have a really good looking game now, with all of the cool mechanics and animations set up properly. And now we're just going to add the finishing touches when we collide with that obstacle to create a really cool smoke effect. So, to do that, we're actually going to learn how to use particle effects. Now, if you go into your assets, under the course library, there's actually a particles folder. And if you expand the particles folder, you can see there's dirt splatter and smoke explosion. So we're going to take this explosion smoke and drag it into our hierarchy. And then you can see it creates this really cool puff when we place it. And you can see there's actually a little section down in the bottom right of our scene. We'll make that a little bigger. And in this menu, you can actually play, restart, or stop the animation of our particle effect. So if we play, and we can restart as much as we want, and we can stop it, and we can play. So this is just a kind of cool way to see the effects and how they work. Now, another cool thing about our particle system is that there's a whole bunch of options that you can actually change on the particle system to be able to make it do different things. So you can actually go and change how fast the actual particles move over their lifetime. So if we set the speed to be 10 times as fast, should move even faster than before. Yeah, so it's like a big... That's actually kind of cool. I'm going to leave that. So we'll stop that. So it's pretty cool. We can set different options too that we want. So we could change the colors if we wanted to. We could change how they actually expand. All of these other different options. Actually, you know what? I'm going to set the speed back to be 2. So there's all these different ways that you can play around with particle effects. Honestly, you could do 100 different things with them. I'm not going to go too crazy just because the base effect is really good for now, so we're just going to use it. One thing that you want to be really careful of, though, with your particle effects is if you open up the particle system menu, you can actually see there's a play on awake, and if we set that to true, so that would immediately create a huge puff of smoke when the game starts. That's not exactly what we want to happen. That's not the kind of effect that we're trying to create, unless this character were a magician, then it would make a lot more sense. So we'll uncheck the play on awake. So now one thing that we're going to do is actually put this explosion smoke underneath our player as a nested or a child object. So that means that it's an object that is attached to another object. So it belongs as part of that object. So you can actually see player, you can see like the character, and you can see the actual legs that control it. If we drag in our explosion smoke on player, you can see now that player has a smoke explosion effect attached to it. And now what we can actually do is when we play, we can actually like move our particle effect around. So if we restart, see it kind of starts kind of high. So we can actually go and maybe let's just set the Y down to 0 so it's at the bottom of the player's feet. And then we restart, and there you go. Now it's closer to the ground. Maybe we'll make it a little bit higher. Something like, no, too high. 0.5, I think is good. And then play. Cool, so that's a pretty good position. So if you watch at the bottom, it's like a puff of smoke. And it creates a really cool effect. So now what you're going to do is you're going to go into your assets folder in your course library, go to the particles folder, take the explosion smoke, and you're actually going to drag it directly on. Cool, so we have this cool smoke explosion here that we can play. But one of the things that we need to do is actually make it play when the player runs into one of our obstacles. So if I time it right, so something like that, pretty close. The computer can probably do it better than I can, so we'll just have the computer do it. So we can actually do that by going into our player controller script, and then in our player controller script, very similar to how we got our components for our rigid body and our animator, we'll do something similar. In this case, because our particle system is actually outside of our player components, we'll make this a public particle system. And we'll call this the explosion particle. So now this will create one of those variables in our component that we need to drag something onto. So we'll do that later. Now in our player controller if statement, whenever a player runs into an obstacle, this is where we're actually going to make our explosion particle happen. So when the player dies, we can add another line, and we have the explosion particle now. And we can actually just play the particle, and so that entire animation effect will just play as soon as it hits this line of code. So we run into an obstacle, game over happens, player dies, and it'll play the explosion effect that we have. And then in Unity, just make sure when you go to your player object, you take your explosion smoke and drag it down to the player controller script and drop it into the explosion particle. So now, when we press play, when the player runs into an obstacle, we should see a big puff of smoke. Perfect. That's exactly what we were looking for. So now what you're going to do is in your player controller script, you're going to create a public variable that is a particle system, and we'll call it explosion particle. And then in our onCollisionEnter method, where we actually end the game by running into an obstacle, we're just going to call that explosion particle. Alright, so our particles are getting pretty good right now. When we run into one of these obstacles, we get that big puff of smoke. So we're going to add a little bit more to our character. So we have this cool dirt splatter effect. So we're actually just going to drag this onto our player. And now we have that dirt particle effect. Now it does look a little weird. You can actually see it's like spitting out in front and in this case to the side. That's not really how running works. So we're going to make it so that we can face this dirt particle to the back. So what we'll actually do is we're just going to use our rotate tool in the top left. We're just going to rotate this, I think, on our Z-axis. There you go. Looks pretty good now. Probably like directly to the back. Cool, looks good. If you want to, you can I'm just going to clean up this value in our rotation, so I'll set it to -90. That way it's definitely facing backwards. And then if you want, you can even mess with the Y rotation and make it face a bit more upwards or downwards if you want to. Up to you. Really whatever you want to do. I think that angle is pretty fine for me. And then we're going to go into our player controller script once again. And then in our player controller script, just like we did with our explosion particle, we're going to make a public particle system so that way we can attach it. And then this will just be, we'll call it dirt particle, very simple. And then what we actually want to happen is when we're jumping, we actually don't want to play our dirt particle anymore, so it's always playing already. So we'll actually set our dirt particle, let's see, dirt particle, so we can play. So I wonder if we go through the options, is there, so we can stop. So that seems pretty helpful. So let's stop our particle from playing. And then when the player lands back on the ground, that's when we want it to start again. So we'll play when we touch the ground. And then it would look pretty weird if dirt was still coming out from behind the player if the game was over and they died. So we're just going to stop that particle from playing when they run into an obstacle. Now when we save, so you can see when we go back into Unity, in fact, the play on awake is actually set to on for our dirt splatter, which is fine, so that you can see it when the game actually starts. And then when we press play, you can see we're running, we're making dirt, and then we jump, and we're still making dirt somehow. Maybe it's stuck to the player's shoes. That probably doesn't make any sense. Well, the explosion still works, so that's cool. Now you can see that there's just magical dirt being thrown out into the sky. Maybe there's like an animal underneath the player that's actually creating the dirt. Who knows? I think we might have skipped a step. You can see, oh, so in the bottom, we have an error, so dirt particle has not been assigned. So I believe, so in player, see, so under our player controller script, we didn't actually give it a dirt particle. So we'll just take the dirt splatter, drag it, drop it. Now, when we press play, the dirt starts, which is great, and then we jump, and no dirt, and then there's dirt, and then no dirt, there's dirt, and then we run an explosion. And no dirt. Perfect. Cool, so we're really running now.
This one I actually took a bit slower on, so let's see. I'll put this in our void update. Up. It's on ground, dirt particle stop, yeah. Oh yeah, I always forget that you have to add the thing. Oh wait, no, I had it to the wrong spot. Why it's good to double check. It has to know what it's stopping, and I didn't define that. And then this one's just dirt particle. Play. And then we want dirt particle stopping. Okay, and we'll go into here. We'll see it pop up under the player, and we can just grab our dirt slider, throw it right there. And now we should see it spewing at their feet. And stops there. I didn't want to do that. Move it just like a little teeny bit, I think. Yeah, that looks a little better. What if I made like 72? That looks a little better. I just wanted to clean it up slightly. And we already know how to add music. So I wonder if I should skip over this part or not. Select our main camera object, add component, audio source. We've done that before. We had that in our audio stuff. We're attaching it to the main camera. And we want our music. Just throw this one over. Okay. Reduce the volume so it's easier to hear sound effects. I think I had Unity turned down still. Yeah, I have Unity turned down to like 5. I'll just turn it to 10 so we can hear it in general. Check the loop checkbox. Okay. Declare variables for audio clips. Okay, so these ones are public because we're just gonna drag and drop them. Jump sound and a new public one, audio clip for crash sound. Okay, I feel like I don't need to worry about this either. Yeah, I feel like the next one is the one I'd want to look at. But I'll go into my player stuff and declare more variables. Audio clip. We'll name it jump sound. Then we create a new variable. Public. Audio clip. Death. Crash thing. Okay. We're not calling it death. Unfortunately, they don't die. But yeah, this one we'll actually listen to. Zooming through this part.
Cool, so we've added our sounds for jumping and crashing, which is great. Now we're going to go back into our player controller script, and we're just going to create another private variable for our component. So this one will be, in this case, since we want audio, right? We want to be able to emit the audio from our player, so the player needs an audio source. So we take the audio source of our player, and we'll just call this player audio. So this is the audio that plays from the player. In our start method, we're very familiar now. So we'll use our player audio variable, and we're going to set it to our audio source component. So get component audio source. So now, since we have our jump and our crash sound, what we need to do is actually play those audio clips. So down in our code, when the player jumps, we're actually going to use our new player audio variable. And we're going to use a new method. And so there's specifically one called play. There's a play on awake, so when anything starts, it'll play. And then there's a play one shot. So basically, that'll just play it once, and then it'll be done. So we play one shot, and then we want our audio clip, so this is our jump. So our jump sound. And then it looks like there's another variable that we can add, so we can actually change the volume when we play our jump sound. So we'll just set it to be... We'll just leave it to the full volume for now. And then we're going to do the same thing, but when the game is over. So we're going to use our player audio, and we're going to play one shot because we actually need to use audio clips in this. And then in this case, we're going to use our crash sound, and we're going to set it to full volume once again. Cool, now we save. So when we go back into Unity, now when we play our game, we should hear some effects when we jump and when we crash. Then we jump, and I didn't hear anything. What if we crash? What's gonna happen? It didn't seem like anything happened. Let's see. Let's look at our errors. There's no audio source. Oh, I made a mistake. So in player, we actually need to add the audio source because we didn't actually use one. So let's go add a component. We're gonna look for an audio source. There you go. So now that we have the audio source that we're using and we have the clips that the audio source will be playing, now when we press play, that error should go away. And we jump. There you go. And then I can't stop jumping right now. It's just too exciting. And then when I crash, finally... Nice. Awesome. So, now we have an amazing game full of sound effects and audio. So what you're going to do is you're going to make sure that you add an audio source to your player. Don't make that mistake like I did.
Why would we make that mistake? We're not dumb, teacher. No. I get why they do that. It's just to be the... Well, other people might actually accidentally forget about these parts, so it's good to show that you can still fix it even if the accident happens, or whatever else. Balloons, bombs, and bullions. Okay, so this is a challenge one. Want even more challenges? Do your main prototype within range from easy to expert. Bonus feature tutorial. Remember, turn here when you're done to keep learning. I didn't look at this yet, but I'm just looking at the bonus one real quick. Does this one have a submission thing? Oh yeah, it does have a submission thing. Convert the prefab folder inside the spawn manager to an array. Try using a boolean to limit the player to double jumping once. Dash ability and score. Try using a boolean to determine whether the player is running fast. Game start animation. Try lerping the player's position. Didn't they have a do later button on these? I always forget. I think you just have to complete one step. Oh yeah, it's save exercise for labor. There it is. I do like to try and do those later on, just to see if I can manage it. It's probably good to know anyway. This has some download files for it, like all the other challenges have. So I'm gonna grab those right now. It seems like we'll probably be able to finish this section. Booleans, I guess, are easier than I would think. They're just true-false statements. That's good to know. I think it'll be confusing for me to get the you double up the and and equal sign for some parts, but don't always. That might be confusing. But do what you can. Do what you can. I also haven't taken a break in a while, so I'm gonna do that when I am done downloading these files in here. Ahem. Ahem. Okay, got a bunch of stuff. Throw it up in here. Throw it up. Recess buff, recess buff. Recess buff, recess buff. Challenge 3 has a different thing for it. Okay, well we got all that stuff there. Make sure I saved all my other junk. Might try to clean up some of the scripting files, just so I can know for myself if I copy and paste that some of my advanced scripts that I'm just saving just for future reference. But I'll be right back, let the music play, and refill my water and all that junk, so maybe I'll find a snack. I didn't really eat much for lunch. Ah, okay. The final frontier. What is it? But this. Along with the Starship Enterprise. Weird. Blah blah. Looking through junk. Stretch out the arms. Stretch out everything. Okay. Well, let's look over this. Get into it.
Welcome to Challenge 3. So, let's review what we did for our Unit 3 project. So we have our game here, and we have the cool, awesome sound effects and background music to make our player jump. You can see that background is scrolling and it repeats all the time. We have all of these different objects spawning. Cool. And then when we hit our object, we have a huge puff of smoke. Everything stops moving. So we have a good little game on our hands here. So let's see what this challenge is supposed to be like. So let's see, I'll press play. So we have some fun music again, that's exciting. So we have a balloon, and when I press spacebar, instead of jumping this time, it's floating. It floats up. And then we have these dollar signs, these money signs, and then we have these bombs. I guess I have to avoid these bombs. Oh, cool. If I hit the bottom of the ground, I actually make a bouncy noise. That's fun. And then you have these cool effects that pop up when we grab the money. Let's see what happens if we hit a bomb. There you go. A balloon falls, the particle effects happen. Okay, interesting. And then the background also stops now that the game's over. So that seems like a fun little game. Seems super upbeat, enjoyable. Alright, so let's see what's happening with our starter project. So, cool, audience playing. Okay, that was weird. I can't even control my player. Wow, this background is really disorienting. Okay, so the background is still moving, even though the game is technically over. Let's see, what else is happening? Okay, the particles are kind of off there. There's not even any objects spawning. Okay, so there's a lot of stuff broken here. This is okay. Well, let's figure out what we're gonna do here. So for challenge 3, we have a lot of different problems. First up, our player can't control the balloon at all. We want the balloon to float when we press the space bar. Our second problem, the background only moves when the game is over. The background should move at start and then stop when the game is over. No new objects are being spawned, so we're just stuck with that dollar sign and that bomb that are there at the beginning. When we pick up that money symbol, the fireworks display in the center of our scene, which is not right. And then last but not least, our last problem is the background doesn't repeat properly at all. So we need to make it so that background repeats seamlessly. In terms of bonus challenges for this challenge project, one of our challenges is that the balloon will be able to float way too high, and so we actually want to prevent the player from floating their balloon all the way into the sky. And in fact, our balloon can also drop below the ground. That's definitely not how ground works, so we'll need to make it so that the balloon bounces off that ground, so we can keep the player within this range. So if we take a look at our game, in our scene you can see if I get our balloon all the way up to the top, you see it that it doesn't go all the way up, it gets blocked. And then in fact, if I let go, our balloon does this cool little bouncy effect. So it makes a fun little noise too. Now, as you're going through each of these challenges and fixing each of the problems, if you ever get stuck or you need any help, remember that you have those hints that you can take a look at in case you need to remember how to do something or you need a little bit of help along the way. The bonus challenges are there just to push yourself a little bit further if you want to be a bit ambitious and make your project a little bit cleaner. And then if you get stuck at all, make sure you check out the instructions in your starter project. And then there's that handy little video that you can play to see what the gameplay's like. And with that, I'll let you get started on your Challenge 3 project, and good luck.
Okay. Oh yeah, I didn't turn off my music. That's my fault. Well, doesn't matter too much. We looked over the overview. Warning. It's supposed to have bugs. Oh, I didn't realize that. The player can't control the balloon. You should float up as the player presses the spacebar. So, let's get in these challenge folders, the challenge scripts. Let's first make sure that anything has the player controller on. Okay, it does have player controller on. It has a game over switching up. Has a float force. It has mass. Has gravity. Has a box collider. Which, I mean, I suppose that's fine. It's frozen on the X and Z positions, which is fine. Wait, is that fine? X would make it. Yeah, that's fine. Because we're just simulating movement. And that's why it's spinning. If it's spinning, doesn't it mean that it has to spin on the x-axis, though? Let's just start pulling up these scripts right away. That's move left script, that's player control script. This is the repeat background script, and this is the spawn manager script. Okay, so usually what I like to do first is try to just see and compare what some of the differences are between our scripts and the scripts they got. So let's look. So they have their speed as a public float. That's fine. That doesn't really matter. That just means that we can alter it as needed. They're facing their player controller. That's all good. It's named correctly. They have a left bound -10. We have a left bound -15. So we already know how the backgrounds are, so we should probably just do 15 anyway. Also, this is the, yeah, this is the move left one. Okay. We know the repeating background thing already has a problem, correct? Background moves left by its repeat width, move it to back to the start position. Vector 3, start pause. Pellet clash, blah blah blah. Okay. Start position. Start pause. Start position equals start pause. Transform X less than X minus repeat width minus repeat width. Repeat width, get component, box collider, divide by 2, repeat width. It's using the Y axis. So we don't want that, we want the X axis. So the repeat width, the background. Start pause position. That should be fine. Okay, then the spawn manager. We got our spawn manager over here. Okay, they're using an array. That's okay. It's allowed to use an array. It's using floats. Spawn interval, spawn delay. Okay, let's see, this one's a bit messed up. Put random spawn location, random object index. I wonder if these scripts mess with each other, if they're named similar stuff. I would hope not. I don't think they would. Anyway, so it has invoke repeating. And instantiate. Let me look really quick. So, just to show what we have so far before I do anything else. Money bomb. What objects is it referencing that needs referenced? It's on loop. Object reference not set to an instance of an object. Start, add assets, control script. Oh, the start function. Gravity modifier. Audio source. Where is it failing to grab an object? This should all be correct. But is playing nothing right now. Okay, we move that back over where it's supposed to be. There's audio. Why does it need to apply force at the start of the game? Hmm. So if space is pressed and you're on the ground and it is not a game over, you can jump. And this one is if space is pressed and it's not a game over, you can add force to the vector up. Jump force, 10, force mode, impulse. That's immediately. This one is just using float force. And float force isn't defined as anything. That'd be like the jump force, which you can modify. But it should still be set to impulse, right? Actually, no, you wouldn't want it to be like that, right? You would want a continuous force, right? Make it float? Or do we want a different one? Or would you just want to get rid of gravity? No, I feel like that wouldn't matter. So right now I can't even play the game because it keeps saying that it's wrong because of whatever this error is. Null reference exception. Object reference not set to an instance of an object. Player controller X. Start. Add assets challenge. 3 scripts. Player controller X. I don't understand what it's having issues with. Hmm. Yeah, see what's being done. How do I do that? Why is it not getting whatever this reference is? What is the reference it's trying to get? I don't understand. As the blip, as the boing, as the boom. Actually, it doesn't end in boing. Got the other part. It's an explode sound. So we want it to play the money sound when it collides with money. So we would go into collision. So if the player collides with a bomb, it'll play the bomb sound. And if they collide with the bomb, it plays the true, the game's over, and it destroys other object if it is there. And then if the player also collides with the money, and we want to play the firework particle? What? Explosion particle. Particle system. Okay, that's correct. Where did I put those? Yeah, put those there. That's in the right spot. Explode sound. That's in the right spot. Spelled correctly. Plays once. Plays once. Oh yeah, the tags could be wrong. Money and bomb. Okay, well the tags are right. As being referenced are correct. Player audio being referenced is correct. I don't know what I'm missing here. Give them. What is it not being able to grab? Non-reference exception. Object reference not to an instance of an object. Just looking at something. Okay, so what do I do? This one. It is under the start. I feel like I just don't need this here. Do I? Well, it plays in general, but when I'm hitting space, it's ending the game. Okay, so what does it want now? Object reference not set to an instance of an object. Why? Why is it not though? Trigger. I'll just try it like this. Okay, here. I'll delete this too. Is there still some issue? Spawn manager X. Spawn's object shouldn't be called. On obstacle. On objects. Hmm. Engine scale. Oh, that's false. Okay. So, before the game over was not set to anything. It was a bool, but it wasn't set to true or false. So I set the game over to false. So, now it has the stuff for if you hit the bomb, the game over goes to true instead. As well as if the game, if you press the space bar and the game is not over, then it'll let you flow up with impulse. We might need to change that though, but we'll see if that works at all. I don't know why it's shutting off the thing when I hit it. There's nothing that makes you exit the game. Vision. Hmm. Oh wait, it's saying it collides with something else. Is it colliding with something else when I hit space? Is that the issue? These don't have colliders on them though. The box collider is fine. That collider is fine. That collider is fine. Main camera doesn't have a collider on it. Directional light doesn't have a collider. You would hope at least. On manager does not have a collider. So why is it turning off stuff? When hitting the space bar. Hey again, Jordan. I'm doing a challenge. Just out of curiosity, what if I hit up? What if I made it the up arrow? Does that matter? Is it just some weird issue that's happening for no reason? No, that's making it fall still. But I don't get why it's making it fall. What is happening in this line that is not letting it function correctly? Yeah, I didn't even figure out this. I didn't figure out the most simple step. So, no, actually. The background is also not moving. Destroy game object. Tag. Why is it only doing it when the game's over? The game is the game. I don't know. Maybe if I give it a variable, it'll work for some reason. Well, give it a number. I don't know why that would change it at all, but maybe maybe it would. This has to be space either way. Okay, so what happens now? Okay, well that moves. But when I hit the spacebar, it still keeps pausing it for some reason. Object reference not set to an instance of an object. I'm just gonna look this up and see if I understand. Because I don't understand right now. You're referring to an object that does not exist or was deleted or cleaned up. An object that does not exist or is cleaned up. Rigid body, player RB. Oh wait, does that mean it doesn't have a rigid body on it right now? No, it has a rigid body. Okay, it has a rigid body. That still exists. It's being referenced properly. Boat Force is also being referenced properly. Game Over is being referenced properly. Then what's the issue? Did I miss parentheses somewhere? Being multiplied, force mode impulse. That wouldn't matter. I don't understand. Player RB. Rigid body. Player RB. What is the issue? I don't understand what the issue is. This is the crappy part about learning programming. Not having an idea why it's not working. A link to an object. References can be used exactly like the linked objects rather than holding a copy of the object. Each assigned property holds object references that link to the same object so that when the object changes, all properties referring to the object have to change. What happened? What am I doing wrong? It wants you to use the rigid body thing. Because you use the rigid body to apply the force, then you apply the force up. And we're applying jump force onto the player controller. But it's not working. It detects that we're hitting space, but it says that we're not allowed to hit space, so it pauses. Why are we not allowed to hit space? But I don't get here. Why would that happen? I don't understand what the problem is. It's telling me to make the field read only, but what would that do? If it's only reading it, doesn't that not... It don't really matter, right? Curious what happens if I make it read only. What is the conflict? It's still freezing it. This music is perfect, like something that would play in a cartoon episode while you're thinking. It's fine. The music now is very soft, though. I don't get why this is still not working. This one's simple. It works. It does what it's supposed to do. Setting it to read only shouldn't matter. Wouldn't do anything. What is that? What the heck is the issue? We're keeping it in that bracket. Here, out of curiosity, I'll just completely get rid of that line of code. We'll ignore the game over completely and see if that's causing the problem. Nope, it's still having the issue. Still same line of code. Well, now I don't know if just some reason it's a game. It's a gamer. It's a gamer problem. I don't know for some reason if it's a naming convention problem. I don't know why it would be a naming convention issue. But about all I can think of right now. So I guess I will just name this something else. Work. Player work. Not referenced anywhere else. Okay. What happens if I rename it something else? Still has the same problem. Still the same line of code. Okay, here. What if I just get rid of all of the code in that? Still same issue. What the heck is happening? I don't understand what is wrong with this line of code. Why does it want it to make it read-only so badly? Why can't it use the rigid body? Why does this one not have an issue? No. I think I just realized what happened. Now I realized what happened. I realized my mistake. I'm being dumb. I didn't define the object in the start, so that's why it wasn't doing. And now I just feel silly because I didn't realize that sooner. I wonder how many programmers have to deal with that stuff. Yeah, I needed to define the player RB as get component for rigid body. So now that should function correctly. Okay, so now when we hit play, okay, it does not crash. It just shoots the balloon up very high. And yeah, we probably should change that. How heavy is a balloon? A balloon isn't supposed to be heavy though. We should probably just turn the float force down a bunch. I don't know, I'll just make it 2 right now. It comes back down. We probably want to put some weight on the balloon then, I guess. We'll just make the balloon 10 kilograms. How about that? We die. Okay, this isn't terrible. We can hit those. We can run into the bomb and die. The screen stops. Okay. Now we're doing a bit better. I had so many issues with that one. But now we're doing a little bit better. I liked how the issue I had was not realizing one parameter thing. Okay, well, let's go through this. We can control the balloon now. We can hit spacebar and it moves up and down. The background only moves when the game is over. It doesn't. The background stops when the game is over. The background moves when it is not. No objects are being spawned. Objects are being spawned. Fireworks appear to the side of the balloon. We fixed that already. Fireworks are inside the balloon now. Background is not repeating properly. I think it's repeating properly, right? I wasn't really paying attention. It is, right? Yeah, that looks like it's repeating properly. Okay. So, it is repeating properly. Can float way too high. So we want it to not be able to float that high. So that's hard to think of. We didn't have a jump limit. Right? Like, the character can jump, but then he weighs so much that he and or she just falls back to the ground. There's not like a... if your height's greater than... That's what I need to check for, right? Oh yeah, I need to rechange this also. So, if you hit the space key and the game over is false, you can jump. And then, if you hit a bomb, set game over to true. And then if it was true, wait, no, I want to change that differently, right? Yeah, game over is not false. Well, it's saying it is not false. Right? I do that right? Or do I need to change that? Let me just do that really quick and see something. Crashing this bomb. Actually, it destroys the object anyway, so I wouldn't really be able to check, would I? I know, I'm too good at this game. Okay, we were hitting space and we can't float up. So, that is correct. No need to worry about that one, then. You can drop below the ground. Huh. So, we want it to not be able to hit over the top, and we want it to bounce off of the bottom. Prevent the player from bloating their balloon too high. From floating the balloon too high is pretty easy. I could just put a ceiling onto the thing. That's just out of view. That'd be kinda simple to do. Like, I could set a script for it, but I feel like it would just be easier to throw a new object in over top, right? No, it is supposed to be a programming thing, so I should probably make it so the script does it instead. So we would just want to do, if it's above a certain limit, you can't jump anymore. That's what we would want to do. So we had the is on ground thing, which we had as a bool. but that's just colliding with the ground. So you'd want to set a vector as a bool, right? Like if you're above this certain point, check a box. Or what? On collision, enter. So it's when it's colliding with the ground. I mean, this goes below the ground though, right? Where was the example thing? I wanted to look at that really quick. They're just showing in the video what we already have. I wanted them to show the bounce effect. So we could do it in two ways, I guess. That's how I see this. If collision game object can paracran ground. So yeah, I feel like it would be easiest just to do this. I'll create an empty called sky. Transform it, change position. Bring it up. Main camera can't see that. Okay, then we add a component, add a collider. Well, we don't need a trigger actually. We'll just create a tag. Tag it to sky. Make the tag sky. But I mean, I guess we don't really have to make it that big either anyway. It's not technically moving over. Do that. So then when it collides with the sky, I mean, I could just make it a rigid body. Also. But that would make it hit it. So it'd be easier to just make it not be able to fly up that high. We probably actually want to lower it a little more than that. Maybe. We can't see it. I think we can do a little lower than that. Okay. So, now we have a sky. And we want to say... and sky, pretty much. We want to add a collision that detects if it's touching the sky. How many else ifs can you add? So if collision, blah blah blah. So if collision oh, what are you doing? Tag. We want to set. Start. You don't define game objects in this one, right? You have a game object. Compare tag, else if. Compare tag. Yeah, what the heck? That. That's because I made it in capital, so thank you. E-O-L-O. What is going on? What is going on? Oh, that's what's going on. On collision enter, right? Blah, blah. Okay. Okay, so then we want to make our if statement. So if it collides with a game object, and that game object is compare tag the sky, then we return touching sky equal true, I guess. Then we have these public. Yeah. Alright. Equal true. Okay. So we have to set that to something else now. So this would be so in the first project, well, in the project we were just doing, for project 3, if you hit the space bar and your character is on the ground and it is not game over, you can jump. So we want it to be if our character is hitting space and it's not game over, and they are touching the ground. I mean, they are touching the sky, or they're not touching the sky. So if the character we have to make it rather big though, then I feel like I could do this more efficiently in a different way, but pretty much we want this whole section to be touching the sky. So if they're touching this area, they can't move. They have to go back down. Maybe just make it a little bigger. Okay, so if they're touching that, they can't jump, is what we want to do. So if they're colliding with the sky, then touching sky is true. And touching sky right now is set to true. So we want to say if they're hitting space and the game isn't over and they are not touching sky, then they can jump. But if they are touching the sky and it's true, then they can't do it. I think. I might have written that the wrong way. But we'll see. This is more or less my first time trying to make it this way. The show back later. Of a show. Oh, you weren't saying the name of a show. Okay. I did it the wrong way. So wait, would I just want it like that then? So if I read it out now, it would be, if you're pressing the space bar and the game is not over, and you're touching the sky. Wouldn't I just want to make that false then? I don't know. Let me look. I mean, that works. So then if I duplicate this, if I change the name to ground, if I make it, let's say, it's about at that level. More or less hits the tree. Actually, would I need that then? It looks like it hits the ground more or less, but it's like a little under the ground. I guess I can just use the ground. Yeah, I can just use the ground. It already has the collider on and stuff anyway. Okay, so then we stop the balloon from floating. So now the balloon can drop below the ground. Make the balloon appear to bounce off the ground, preventing it from leaving the bottom of the screen. There should be a sound effect when this happens, too. So, if we look at our code, we want it to collide with the ground. So this one, we'll just do another public rule is on ground again. And we'll do this one set to true also, like before. So we want to make another if statement. Wait, why was that one blue? Oh, I think I need to write it in here, right? No. What am I doing? No, I do want to write in here. I don't want to enter here. I'm being dumb. So, if collision game object compare tag ground then we want it's on ground to equal true. Okay, so so if it collides with the ground, then it collides with the ground. Nothing happens right now if it's colliding with the ground. We want a sound effect to play if it collides with the ground, though. And we want to apply force if it hits the ground. On collision, enter other. On collision, enter collision. Hmm. So we need something else for this. What would we need for this? If it hits the ground, we want it to play a sound effect. And so it'd be kind of like when you're dying. Except we're not going to play the death sound. Oops. Don't do that. Does this have like a squish animation? Does it have a squish animation? It doesn't have a squish animation. We would have to make our own animation if we wanted to do something dumb like that. But, that means we'll need to make a different sound first. We need to make a bounce sound. Boing. Okay, so then we can just reference the death trigger. And you have to think of how we're gonna do this correctly. Blah, blah, blah. So in our original one, we have if you collide with the ground, ground's true, the dirt particle is playing. So that means instead of the dirt particle playing, we want to play the boing sound. But we only need to play it once. So if this happens, we want to play our bounce sound. Make sure I write this right. Why is it not coming up with the correct thing? Spirit particle system. Wait, would I just do play only then? Oh no, I would do player audio. Oh, okay. Okay, yeah. The particle thing was because you're referencing the particle effect. We're referencing a sound only, so that was my bad. My bad. My B, bro. Okay, so in theory now, when we hit the ground and collide with it, it should make a bounce sound effect. So let's pause this for now. I did, what did I do here? Oh. I didn't have the ground tag. Did I do it wrong? If you're colliding with a game object, ground, then play that. If you're colliding with the ground, then play this once. What it should be doing. Accidentally just shut my music off now. Oh my god. Okay, it might be doing it, I just can't hear it also. Let me turn Unity up really quick. That sounds a bit overly dramatic, but let me lower this down to like 50% or so. Can I still hear this? Uh, okay. Maybe it'd be easier to do what I was trying before. Should probably still making touching ground is game over though. Well, I guess it doesn't have to be game over because the game over is if you hit a bomb, so that wouldn't make sense. Why is this one not working though? Is my coding somewhere incorrect? Or is it because it's using a different ground? Player, camera, motion, background, bomb, money. Don't know. This one's untagged also, but then when I made the tag for that one, let's just try to make a tag for this one and see how that works. We'll make it ground 2, electric bungalow. Okay, we name that ground 2. And player controls, ground 2. spelled correctly. We'll check that really quick. Okay, as far as I know, I spelled it correctly. I'm not hearing it collide. It should just be when you're hitting the collision with it. Maybe I should up the collider. It has a mesh collider, but I can't increase the size of the collider. Can I just put a box collider on top of it? Bit too big? There, what if I do that? Is on ground true? Is on ground true? And if that's true, we want... I'm curious. Uh... Why is it not doing it? This is the part I don't get. We have it not fall through the ground, but it's not playing the sound to do the little blip. There's a representation of audio sources. There's an audio clip and scales the audio source volume by scale. And then it's playing the bounce sound once. Just like it plays the money sound once. The whole entire thing with ground 2 isn't working for some reason, and I'm not sure why. Why is it not working? Let's see if it says anything about the balance. Figure out a way to test if the balloon collides with the ground, then add an impulse forced upward if it does. We're adding an impulse force upward, but it's not doing it. We're saying if the game object collides. Do I want to set this to false? Is that the problem? Is that what I'm not understanding? Because it's set to true automatically, I'd have to set it to false? Or would this ruin things? So if it's touching the sky when it collides with it, that becomes true. If it collides with that, it becomes true also. So wait a second. Do I even need that there at all? I thought it'd be easier to just do this, but maybe it'd be easier to just... Do this. Yeah. Move -3. Uh, Volume, mute, audio clip, playing. It said that it's playing it, but I can't hear it. No, it's not. I can hear it then. Okay, if it's turned into a trigger, it goes through everything. So I can't use it like that. Hmm. Why isn't this stuff working right then? I know I don't need to do this, but I want to just see if I can do it. So I can learn more. So let me just look back at here again. Is it just because I should put an else if to it? I don't know. We have this here that's if it collides with game object ground, then you can play the particle effect. And then, or else if you don't do that, and it collides with an obstacle, the game over. The particle effect stops, and you get to play the audio of, oh, you die. Oh, I think I realize what the problem is. We don't have anything saying when we're not on the ground. So wouldn't that mean we want it to be when we're on the ground? Or I guess it would be better to call this in air is true. And then in air would equal false if we're touching the ground. But we need to define when we're in the air. So we just need to say we're in the air always, unless we're touching the ground. So we would just put it here, right? So, oh wait, this is the wrong place. When you are just existing, every single frame, it's saying that you're in the air, right? And then when you hit the ground, it's false. And then we would have the bounce sound. I think this would be it, but I've been wrong already. And I think I already sort of tried this. Okay, so hmm. Still not making the sound. So should I do this is true? And this is false? And would that be right? I don't know why it keeps going so slow now. Also. Here, let's turn this back to 10. Hmm. I don't know. I shouldn't do anything at that part. This one feels a lot more normal. But we're still not getting our bounce effect when we hit the ground. And that's all I'm trying to do. And I don't know why it's not working. It should work exactly like the death animation. When we hit the ground, it should just play the sound once. And then when you get off the ground, it turns off the checkbox that you're on the ground. And then you hit it again, and it bounces again. That's what should be happening, but it's not happening, and I'm not sure why. So what the heck am I doing wrong? Do I need to make it an else if? Is that why? I feel like that wouldn't matter. The problem with this thing is, you know, this is saying if you're hitting the space bar, then you're not on the ground. So the ground is false. But I can't use that same method, right? Because it's supposed to always be in the air. But it should be reversed, is what it should be. But how do we reverse that? I mean, I guess the idea would be it would be easier to just make it on the collision with other. Maybe that's the issue. And it's if player collides with bomb, explode and set game over to true. If player collides with money, fireworks. Other. So if it hits a game object, and the game object is if the game object is Grand 2, then you get player audio, play one shot. Bounce sound. But you also get the impulse. Can I just add? No. Applies force at position. As a result, this will explosion force. Applies a force to that simulates explosion effects. Adds a force to the rigid body also to its coordinate system. Adds force vector force mode. Or just add force to a rigid body. So instead of hitting space to add force, we're getting force added to us when we're at a specific position. So the force being added is upward. then the position it's at no, it's -3. And we'll just say 0, whatever. Oh yeah, I could just make this vector up too, couldn't I? Well, we're getting the sound now. We're getting the bounce sound, but it's not shooting it up. So I want this to be equivalent to our position, right? How would I get my position? How would I get my position? How would I get my position? Where? Um, okay, so Pushing air in air. Controller, game over. Right, I can't do that. It has to be on something else. Force or position, but I don't know the position. I could just make a range, right? I could create a range for the position. Let me see. Float delay, float range is what I'd want. So we'll have that. I forgot to put this on again. Okay, so yeah, hey again, Jordan. I'm still programming. Okay, so I want a random range. And we want the random range to be on the y-axis. So we want it to be between 0 and we'll just say like 4. And then for this, we can just do 0, any y, 0. Okay, maybe then we'd have to do how do you make the new vectors again? I haven't done this in a while. Hot pockets? What? P. Does that not work? I don't remember how you do the new. How do you do new again? I haven't had to use new in a while. I don't remember how you use new. None of these have examples. I didn't write down any examples for new. Oh, okay, there's one. I need to do vector 3. Any y2. New. Equal. Oh, no. I want it to equal here. So then I should just be able to do any y2. Okay. Well, that was a process that probably took too long. Anyways. It's making the beep sound when it hits it, but it's not shooting it upward. It's not forcing the movement to go up. Weird. We got the sound to make it bounce, but it's not bouncing upward. I'm not sure why it's not bouncing upward. I have it adding force at the position to the rigid body, but apparently that's not what I want to do. So what do I want to do for it? It's if you touch the ground, it plays the bounce audio once.
Welcome to Glimmer!
But I need it to hit the bounce audio. Well, I need it to hit the thing, and then do the other thing. What was that name? TikTok was. Thanks for the follow? Question mark. Unless you're a robot, then still thanks anyway. I wish my brain could handle this easier. If the force is being applied to the rigid body, and it's sending it upward, it should work, right? That's how it should work, right? But do I need to apply a force greater than the mass? Is that the problem? Am I not applying enough force upward to it? So the amount of force it's applying right now is 1. It's applying 1 force. So we'll make it, we'll just make it 10 for right now. Did I save that? Okay, so it's making the sound, but I do not see it applying force. Why is it not applying the force? Adds an instant force impulse on the rigid body using its mass. So it should be applying a force of 10 to it anyway. I don't know, I'm gonna make this an insane number and see if anything happens. I'll make it 1,000. Just to see if that does anything differently. Maybe I'm just using too small a number. Oh. Well, that one just zoomed quick. I guess I was just using a too small of number? I don't know. Let's make it 50. This is probably why programmers need to know math. Okay, well now it's bouncing. Huh. Okay, I guess I was just using too little. Let's make it like 80. I feel like that's okay. Not that it matters too much. I don't know why I'm putting so much effort into this one. Yeah, that's a lot better. Now it's actually bouncing off the ground. You can't hit the top, it bounces off the ground. Can't fly off into space. We have a skybox. It bounces, it makes the bounce sound. We can explode ourselves. It makes the fireworks when we hit the money. Oh, right. It keeps bouncing when the game over happens. Wait, would that do what I needed to do? If you hit a bomb, it changes to true. I need to do an and here, wouldn't I? And game over. I think that's what I want. It is not game over. If it is not game over, you can go up and down. If it is not game over, you can bounce. I think that's right. I think I did that right. I don't know, I guess we'll find out. Still bouncing. And then we hit bomb. Okay, yeah, I did that right. Yay! I actually did it. Oh. It was a bot. Unless that's like a real person that's saying add my game to those things for some reason. Just ignore the meta display there. Oh wait, it wasn't that one. It was this one. No reason I did that. No reason at all. Yeah, that doesn't sound like anything real. Gonna do that. Okay. That's all good. Anyway, we did all that. Oh, we did the bonus challenges and everything. We didn't do the optional thing, but I'm aware of it. I might try those ones later, but we'll see at some point. Now we have the third lab. The third lab. And then we just have the quiz. Oh, I'm getting pretty hungry too. Might actually stop soon. That one took me like 5 hours. Well, everything together has taken me 5 hours. Create player controller and plan your code. Regardless of what type of movement your player has. Okay, so is this just for... This supposed to be for our stuff that we've already done? This is just for a personal project, isn't it? Clear new private, basic movement user. Let me just...
We have primitive objects ready to go for all the main components of the project. But the first and most important element we should focus on is the player. So by the end of this lesson, your core player movement will be functional. Now, depending on the type of project you're making, the player controls may be completely different. You might be able to move all around the screen, jump up and down, maybe just rotate left and right. Whatever the core player control is, it needs to get done first. But after you've programmed where the player can move, you also have to program where they cannot move. For example, if your player can move all around the screen, they cannot be able to leave the screen. If the player can jump up and down, they cannot be able to jump endlessly.
Why not?
That's the goal here. Program how your player can move, and also how they cannot. So to make all that happen, I'll see you in Unity.
Okay, yeah, that was just... This is just the stuff for our personal project, and I'm not going to worry about that right now. I also already programmed player control into a first-person thing, since my personal project is just going to be a quick little walking simulator type thing, is what the idea is, at least. But our quiz. So it looks like I'll be able to just do the quiz, and then we can end the stream here with going into Unit 4. Unit 4 being gameplay mechanics. I'm interested to see the user interface stuff. But, plenty of things to look over. We have to get one answer correct. Really? We have to get one answer correct to pass. We can take it as many times as we want. Oh boy. Let's see if we get at least one. You are trying to stop spawning enemies. When the player has died, and I've created 2 scripts. I'll play my music again. Below to do that, however, there's an error on the underlying code, is alive, and the enemy spawner script. What is causing this error? Public to access the modifier. That one is pretty easy. Matching the following animation with its set of parameters. Aim set bool. Live true. Inch. Animation settings with its set of parameters. Integer, trigger, and blue. Set trigger alive to true. Would it be? No. We would want 2 to be C. I think. Or do you not want it? They have 1 as A, 2 as B, 3 as C. I feel like that's wrong. The bool should be true or false. So shouldn't 1 just be B? That trigger to celebrate, integer to throw type. That doesn't sound right. But I feel like bool is true or false all the time, so I feel like it has to be that one. Given the animation controller state machine below, which code will make the character transition from idle state to walk state? B conditions greater than 25. So the float has to be greater than 25. It wouldn't be that, wouldn't be that. It could technically be either of these, but I think it would be this. Because they're supposed to be floats. Which of these is correct way to get reference to an audio source component on a game object? Get component audio source. It'd be A. Yeah, it'd be A. Question 5. When you run a project with code below, you get the following error. Null reference expansion. Object reference not set to an instance of an object. What is most likely the problem? Public class enemy. Game object find player. On void trigger enter collider other. If player transform position Z. Object reference not set to an instance of an object. What is the problem? Start method should actually be update. The enemy does not have a rigid body component. Player does not have a collider. Well, what I was having the problems with on this was what? we defined what the player rigid body was, but we didn't put the rigid body in the get component thing in start. Reference not set to an instance of an object. I mean, I feel like that would be the simplest way to say it. The player object does not have a collider. I don't know. That one sounds weirdly worded. Sounds very weirdly worded. I don't like it. Interface, you're a user. There's a lot of interfaces. A lot of users. But gameplay mechanics is Unit 4. We're on Unit 3, so we're doing that next anyway. I am curious to play around with the user interface and whatever they're going to teach for gameplay mechanics. I don't know what that's going to mean. I don't know if gameplay mechanics is going to be like popping up text box or throwing a item at someone or something else, but we've done that sort of stuff before. I'm not sure if they'd do that, or if this is just going to be more advanced ones, like the text box pop up. Don't know what that'll be. But, yeah. I wonder if the... Well, no, never mind. Which of the following conditions properly tests the game that the game is not over and the player is on the ground? Oh, great. So, if the game over is not equal to true and is on the ground, player tests that the game is not over. Well, you can't use and, so it isn't A. And doesn't exist. And has to be 2. And for signs. So that means not A. Did I write down what the 2 equal signs meant? Pretty sure I did, but I don't know if I'll understand it even if I wrote it down. Equal to operator. 2 equal signs together. What's an operator? So equal to operator. If game over is not equal to true and is on the ground, I feel like it's C, but maybe I'm just reading it wrongly. I feel like I understand how to read the programming language better now, but then when I think I know how to, then it's like, no, it was actually the opposite. You said it somewhat correctly, but you mixed up the middle words in there that actually matter. It's like, oh, at least I have it right to some degree. Dyslexia for the win. By default, what will be the first state used by this animation controller? Not crouched. Which of the following variable declarations observes Unity's standard naming conventions, especially as it relates to capitalization? That was the sound I did not want to make. Well, it lets me type it in, but I'm supposed to select 2. 4 and 5. Or 2 and 4. I guess it's 4 and 5. Because the vector 3 start pose is what you do for a lot of that stuff. Which of the following is most likely the condition for the transition between run and walk shown below? Okay. Transition between run and walk. Okay, so if you are running less than 0.5, then you start to walk. That makes sense to me, unless I read that incorrectly and they meant the greater than one. Which of the following do you think makes the most sense for a simple movement state machine? A simple movement state machine. What does that mean? What does a movement state machine mean? I mean, like, how simple do you want it? Because this one would, to me, mean that if you're idle, you can go into a full sprint. Or if you're idle, you can just stand still. And then when you start going slowly, you start walking, but then you can speed up to start running. Then you can slow down to a full stop, or you can slow down to walk again. So I feel like A would be a normal movement cycle. Because I don't know why it would be C. So I'm just going to say A. But if they mean C, I'm going to be upset. I got one wrong. Was it that one? Okay, no, it wasn't good. It was this stupid one. Which is following your answer, 4 and 5. Incorrect. They want it to be 1 and 5? Oh, yeah. Okay, so you would still want to have... yeah. I understand now. I didn't think about animator being an actual word for some reason in the language, even now that I know it's an actual word in the language. Okay, well, I do need to go exercise and all that junk, but I'm gonna look at this unit introduction stuff, and then I will stop stream there, I think. That sounds like a good idea, because then I can go exercise and eat dinner.
I hope you're ready, because we are about to get started on Unit 4. Now I know there are a lot of people out there who say that this unit is the toughest one in this entire course. But you made it through Unit 3, and that was no walk in the park, so I think you're ready. In this unit, we will program an arcade-style sumo battle with the objective of knocking waves of increasingly numerous enemies off of a floating island. The player will have to use power-ups in a desperate effort to withstand their relentless onslaught. If it sounds dramatic, that's because it is. In creating this prototype, you will learn how to introduce new gameplay mechanics into your projects. A gameplay mechanic is a rule or system in your game that ideally makes it more interesting to play. One new mechanic you'll learn to program is a power-up, a temporary state that will give the player an advantage. These are not only super fun for the player to use, but can completely change the way a game is played. Now the user needs to decide, should I go for the power-up now? Maybe I should save the power-up. What should I do when I get the power-up? All of these new questions and strategies will suddenly emerge and make your game way more interesting. The other mechanic we'll introduce is if you defeat all the enemies, a new wave will appear with one more enemy than the previous wave, increasing the difficulty over time. This will also completely change the way the game can be played, because instead of being a static experience that the player can quickly master and become bored of, it has limitless potential to challenge even the most expert players. These two gameplay mechanics, power-ups and increasing difficulty, go hand in hand because as the game increases in difficulty, you can introduce new power-ups to match it. This combination basically removes all limitations from your project development because you can continually up the ante, increasing one and then increasing the other in response. The sky's the limit here, so let's start creating.
Okay then. Huh. Well, it seems like Unit 4 is maybe going to be a little redundant. It sounds like a lot of the stuff they're going to teach is stuff that you already know, but they're going to teach you different ways to handle it. It sounds like the user interface one will be the where things get serial. They get super serial. It does seem like this will have a bit to it. This will have stuff that I don't know about. And they'll teach me how to play with camera rotation a bit more and that kind of junk. So it'll be interesting. I'm still just honestly curious, like, when I start doing my own little personal walking simulator thing or whatever, how much would a program like Playmaker actually do for me so I don't have to code? And for the stuff that it doesn't do, will I be able to do what I need to do with the knowledge I'm getting from this stuff? Because ideally already I know how to do things like create and destroy objects when they collide with things, and in theory Playmaker probably would be able to do that too. But if I was making like a little horror game or something, and you're walking through like a hallway, and I want like the walls to shoot out the severed heads of baby dolls or something, I would know how to do that, because I would be able to make a spawn manager and just have it keep repeatedly shooting baby heads out of it and like hit against the wall, and then you'd have to like step all over them, and maybe the baby heads would make little squelching sounds or something, and it'd be a fun little video game that everyone would be excited to play. But I'm still just curious about how I make all the text boxes and stuff. I find it funny that that's what I keep going back to. Like, the most simple thing that'll probably be like to learn to make a text box appear. Maybe it's more complex than I think. I don't know. I guess it'll depend. I'm really curious too to just see like how much Playmaker does for you when we get to that point of being able to actually use it. Though I still think that learning all of this stuff by yourself, without using a tool like Playmaker to do it all for you, is probably a good idea, just so you learn concepts and how to do all this junk. Also, this has a prototype 4 thing, so I'm going to take that and just download that now. I'll probably just set up the starting stuff off screen, but for today, I think I'm going to stop here. I'm gonna go exercise and eat and stuff. I don't know if I'll stream more later tonight. Since I did a 5-hour stream, maybe I'll just take it easy today, and tomorrow I'll do another full day where I write some captions and then do Unity learning in the night or something. We'll see how that goes. I am kind of excited to get to the user interface part, because I want to see how you make your menus and all that junk, and I'm curious to see how that goes. Like, for some things, does making the menu just like create a new scene? But then with certain video games, you know, when you make the menu, you see the translucent stuff behind the character, so that means that it must spawn in the menu, right? And it just makes you control the menu screen then, like an if statement. Like, if you press this button, the menu pops up, and that means player control is false, and then you can control the menu screen. But that would make everything be on the player controller, and that'd be interesting. I guess at least I'm understanding how that stuff could work in theory, even if I'm thinking of it not optimally. Or maybe I am, who knows? But yeah, I'm gonna go for now. For anyone who watched this, hope you enjoyed. Hope you learned something along with me while I silently look at coding stuff. I don't know if I'll, I guess if anyone ever watches this, if anyone ever watches these videos, while I'm still actually learning it, if you ever want me to increase the scripting window here, so it's big and you can actually see what I'm doing, so you can see what I am scripting myself. Let me let me know, because there's definitely different things in here. There's definitely some different stuff in here. Like me making the ground bounce you up that whole entire line. I probably could have made that a little nicer looking when I made the vector 3 with the anything and junk. I feel like I probably could have changed that a little to make it not need 2 lines of code. But it does what it needs to. It does indeed make the thing bounce up. I also could have made the float there for the vector up getting multiplied into its own thing. So I could have just had a word there, like bounce up speed, like I had before. But then I deleted that before also. But there's some random code. I'll have to figure out what code I want to put on my Word documents to save for later, so I can reuse them for other junk. But I'll actually go now. So bye.